What if the oldest written warnings in human history were trying to tell us something NASA refuses to acknowledge? What if, carved into clay tablets 5,000 years ago, the Sumerians left a message not about their past, but about our future? And what if the very institutions we trust to watch the skies have decided that some ancient knowledge is better left buried beneath desert sand? Tonight, we're going to explore something uncomfortable, something that sits at the intersection of archaeology, astronomy, and institutional silence. We're diving into the Sumerian tablets, those wedge-shaped impressions pressed into wet clay by hands that turned to dust millennia before the pyramids rose from Egyptian sand. And we're going to ask a question that mainstream science has spent decades avoiding. Why does NASA, the agency that searches for life on distant worlds, refuse to engage with humanity's first recorded accounts of beings who allegedly came from the sky? Before we descend into this mystery together, take a moment to like this video and subscribe to the channel. I create deep dive documentaries about the Anunnaki and Sumerians, exploring what ancient texts actually say and what modern science won't discuss. Leave a comment telling me where you're watching from and what time it is there. I love imagining this knowledge spreading across the world, just as those ancient scribes must have hoped their warnings would reach future generations. Now dim the lights, let the background noise fade, and settle in for a journey that begins in the dust of southern Iraq and ends with a question that might keep you thinking long after sleep claims you. The discovery that changed everything. Picture this, it's 1849 and you're in Nineveh, up in what we now call northern Iraq. Austen Henry Layard, he started as a British diplomat, now he's up to his elbows in archaeology, stands in the ruins of an ancient palace, dust swirling around him. He's got no clue that the broken bits at his feet are about to shake up everything we think we know about our own beginnings. Layard's crew is digging into the library of Ashurbanipal, the last powerhouse king of the Assyrian Empire. They're hauling out tablet after tablet from rooms sealed tight for more than 2,000 years. At first, maybe they expect the usual: tax records, official decrees, bragging about military victories. But then it hits them. They've stumbled onto something way bigger. This isn't just a stash of paperwork. It's a full-blown archive of ancient human knowledge, including stuff that was old even when Ashurbanipal was alive. Some of these tablets are copies of Sumerian writings, scribbled in a language nobody's going to crack for another 50 years. These aren't Assyrian originals. They're careful reproductions of documents so ancient, even the Assyrians treated them like relics. Ashurbanipal sent his scribes all over his empire, hunting down every important text they could find, determined to assemble the world's first great library. Tucked away in this collection are tablets that go on and on about the Anunnaki, described in such detail, so consistently, you start to wonder if they're more than just legend. Just imagine Layard, caked in centuries of dust, holding these chunks of clay, humanity's earliest written memories. The cuneiform marks are still crisp, as if someone just pressed them in yesterday. These tablets survived the fall of empires, fires, looters, time itself. They waited, buried in the desert and rubble, for someone, finally, to read them again. And then things get weird. As the years roll on and scholars finally start making sense of Sumerian, they notice something odd about those Anunnaki stories. They aren't your standard myths. There's hardly any flowery language, no swirling symbolism. Instead, they're packed with details. Family trees, timelines, astronomical notes, and strangest of all, descriptions of the sky that the Sumerians shouldn't have been able to observe. These tablets talk about planetary orbits, cosmic cycles, and even the precession of the equinoxes, a cycle that takes nearly 26,000 years to complete, which you can't spot unless you're tracking the stars for generations. They've got math involving numbers so huge you wonder what ancient people would even do with them. Over and over, the Anunnaki come across not as vague spirits or gods in some mythic sense, but as real, physical beings from somewhere definite, beings who said they'd come back. Jump to July 1969. Neil Armstrong steps onto the moon, and suddenly, humanity is out there, exploring the universe for real. NASA becomes the face of our curiosity, our drive to reach further. After the moon, they start scanning the skies for life, listening for signals, sending probes, discovering thousands of new planets where life might exist. But through all of this, as NASA peers across the universe for signs we aren't alone, they keep quiet about humanity's oldest written stories of contact, those Sumerian tablets. They sit in museums from London to Baghdad, Berlin to Philadelphia, gathering dust while NASA's budget soars. The gap between these two searches, one ancient, one modern, couldn't be starker, and it's no accident. Now, before you think this is just another wild ride into ancient astronaut territory, take a breath. We're going to dig into this with the care it deserves. We'll check what the tablets actually say, what today's experts believe, and why NASA's silence might be more complicated than simple skepticism or conspiracy. Still, we have to ask the tougher questions about bias, about what happens when new evidence butts heads with old ideas, and maybe, just maybe, whether we've been looking for signs of life in all the wrong places. The Sumerian tablets speak of celestial visitors with a clarity that makes many scholars uncomfortable. They describe these beings teaching humanity agriculture, mathematics, astronomy, and the arts of civilization. They present a cosmology that includes detailed knowledge of our solar system. They warn of catastrophic cycles tied to celestial movements. And they were written down 5,000 years ago by a civilization that, according to conventional history, barely understood the world beyond their river valley. So why does NASA ignore this? Why does an agency dedicated to answering the question, "Are we alone?" refuse to engage with humanity's first written answer to that very question? The explanations you'll hear officially range from "it's mythology" to "it's not our area of expertise" to "there's no scientific evidence." But as we'll explore tonight, those answers might be less complete than they appear. Let's begin where the Sumerians did, at the beginning of everything. The tablets speak of Skies and Cycles. Imagine a scorching afternoon in southern Mesopotamia, around 2600 BCE. The sun hammers down on mud brick buildings packed along the irrigation canals that snake out from the Euphrates. In a temple courtyard, a scribe sits cross-legged on a reed mat, a lump of wet clay in front of him. He holds a reed stylus, its tip cut at an angle, hovering just above the clay. He's about to write down something his whole culture considers vital, knowledge too important to leave to memory, worth the grind of making and keeping these clay tablets. He presses the reed into the clay over and over, leaving those sharp wedges that make up cuneiform. He's not jotting down poetry or balancing temple accounts. He's keeping track of the stars, charting the paths of planets as they drift against the fixed background, figuring out when Venus will blink into view or vanish, even predicting the shadow of a lunar eclipse. The details are stunning. This isn't idle skywatching. Someone been doing this, night after night, year after year, for generations. The Sumerian astronomy texts that survived all this time show a level of understanding that feels way ahead of their era. They named all 5 planets you can spot without a telescope: Mercury, Venus, Mars, Jupiter, Saturn. They tracked their movements closely enough to know where each planet would show up months, sometimes years later. They realized the planets move differently from the stars. They wander, slipping through the constellations, which is why the Greeks ended up calling them wanderers. But the Sumerians didn't stop there. Their tablets talk about dividing the sky into 12 slices, the zodiac, each one matching up with a constellation the sun passes through across the year. They measured the length of a year so accurately they got it within minutes of what we know today. And their calendar wasn't just for show. It actually worked. They figured out how to add extra months now, and then to keep their calendar in line with the seasons. The most fascinating part: Sumerian texts mention astronomical cycles you can't spot unless you're watching the skies for centuries. Take the precession of the equinoxes, that slow wobble in Earth's axis that shifts the North Star, and nudges the spring equinox backward through the zodiac, a cycle that takes almost 26,000 years. No single person could ever see the whole thing. Still, Sumerian math and myth both weave in this processional cycle. That sacred number, 432,000, shows up again and again in stories about cosmic ages or the reigns of gods. Look closer, and you find it's 200 processional cycles multiplied by 60. Seems like they actually grasped this enormous cycle. Their idea of a great year, a cosmic era that matches the processional cycle almost perfectly, pops up right in their stories. It's hard not to be impressed. How did they know this? The conventional explanation is that the Sumerians inherited knowledge from an earlier culture, perhaps one that had been observing the skies for millennia before writing was invented. This is plausible but raises its own questions. It suggests that sophisticated astronomy predates writing by thousands of years, that ancient peoples were far more knowledgeable and organized than we typically credit them. The alternative explanation, the one whispered in alternative history circles and dismissed by mainstream academia, is that the Sumerians didn't discover this knowledge through their own observations. They were taught by the Anunnaki. The Anunnaki, teachers from the sky. You see the name Anunnaki popping up all over Sumerian texts, always spelled out the same way. In Sumerian, it's Anunnaki. Most experts say that means princely offspring or those of royal blood. Anu was their sky god, the big boss in their lineup, and the Anunnaki were his descendants. Now here, where things get interesting. Most mainstream historians say the Anunnaki were just gods, mythical figures in a complicated pantheon. But others look at the ancient descriptions and see something different. The old Sumerian tablets don't talk about the Anunnaki like they're just cosmic ideas or symbols for weather. Instead, they come across as real beings, each with a name, a job, a family tree, and strangely, technology. Let's dig into the actual text for a second because the details are wild. In the temple hymns from ancient Uruk, the scribes wrote up each Anunnaki god like they were keeping government records. Take Enki, the god of wisdom and water. Later astronomers linked him to Mercury. His sacred number was 40, his symbol was flowing water, and his temple at Eridu had something called the House of the Abzu. Basically, the cosmic ocean deep under the earth. Then there, Enlil, who ran the air and basically managed everything on Earth. They tied him to Jupiter. His number was 50, just below his dad Anu's 60, so you see the pecking order. Enlil's temples at Nippur weren't just places to pray. They worked like city halls, resolving disputes, crowning kings, keeping records, holding rituals to keep cosmic order in check. Inanna, the goddess of love and war, gets linked to Venus. Now, this is where it gets really neat. The Sumerians figured out that the morning star and the evening star, two bright points that show up in different parts of the sky at different times, were actually the same planet, Venus. That's not obvious if you're just glancing up at the sky. You'd need months of careful watching and note-taking to realize that. They wrote about Inanna's double-sided personality, creative and destructive, loving and warlike, in ways that echoed Venus's own shifting presence. So, was this just poetic flair, or were they sneaking astronomy into their stories? Maybe both. Maybe they tracked Venus so well, her behavior shaped the way they imagined Inanna. Or maybe they built her up as a character first, then noticed how well her story matched what they saw in the sky. But here's the kicker. Modern astronomers ran computer models on Sumerian planetary records from the Emulapin tablets, those old star books from around 1000 BCE, which actually copy even older stuff, and the numbers are shockingly accurate. Their planetary cycles line up within hours over years. You don't get that kind of precision just by eyeballing things. You need real tools and a lot of careful timing. So how did they do it? The Sumerians split day and night into 12 hours each, but those hours changed length depending on the season. For tracking planets, you need something steadier. Turns out, they used water clocks, bowls with tiny holes that let water drip out at a constant rate. By measuring how much water passed during a star's rise or set, they could time celestial events with surprising accuracy. These weren't just ancient folks guessing at the heavens. They were serious observers with custom tools, organized projects, and generations worth of records. Their ziggurats weren't just temples, they doubled as observatories, staffed by people whose job was to watch the sky, night after night. And that brings us back to the Anunnaki. What sets them apart from gods in other ancient cultures? In Greek myths, you get gods who are basically weather or nature with a face. Zeus hurls lightning, Poseidon shakes the earth, Demeter makes plants grow. You can see the symbolism right away. Egyptian gods often have animal heads, making it obvious they're symbols for natural forces. But the Sumerian Anunnaki, the way they're described is oddly specific and detailed, almost like someone was writing about real people, not just ideas or metaphors. But the Sumerian tablets describe the Anunnaki differently. They have specific birthplaces, not on Earth but in the heavens. They have family trees that are meticulously recorded across multiple texts, with no contradictions or variations. They age slowly but apparently do age. They can be wounded. They eat and drink, not symbolically but actual physical consumption requiring regular supplies. They have preferred foods, favorite beverages, specific dwellings they return to. The tablet known as the Barton Cylinder, discovered in the ruins of Nippur and now housed at the University of Pennsylvania Museum, contains a particularly detailed description of how the Anunnaki organized their governance structure. It describes councils, voting procedures, administrative territories. This isn't the language of mythology. This is the language of political science, of actual governmental organization. American researcher Samuel Noah Kramer, who spent decades at the University of Pennsylvania translating Sumerian texts, noted this peculiarity repeatedly in his work. He observed that Sumerian gods behaved less like divine beings and more like a colonial administration, with clear chains of command, specific responsibilities, bureaucratic procedures for decision-making. Kramer never endorsed ancient astronaut theories. He was far too rigorous a scholar for that. But he acknowledged that the Sumerian portrayal of their gods was uniquely concrete and organizational. Take the tablets that describe the divine boats of heaven and whirlwind chariots. These craft are depicted as vehicles that could fly through the air, making tremendous noise and leaving trails of fire. In the Epic of Etana, the king flies on an eagle's back to reach the heavens, seeing the earth shrink beneath him until it's no larger than a garden, and the ocean no bigger than a bread basket. The description of seeing Earth from altitude, with its curved horizon and diminishing features, doesn't sound like pure imagination. It sounds like someone trying to describe something they'd actually witnessed or been told about. Let's examine the Etana epic more closely because it contains details that are remarkably specific. Etana doesn't just fly, he describes his journey in stages. First, he rises 1 league into the sky and looks down. The land appears normal, still recognizable. He continues upward another league, and now the land begins to look different, smaller. By the 3rd league, the sea appears as a small pool, the land as a garden plot. The progression is systematic, describing what we now know are the actual visual effects of gaining altitude. Ancient peoples couldn't have experienced this perspective naturally. No mountain reaches high enough to make the earth look small. Even standing on the highest peaks accessible to ancient Mesopotamians, the curvature wouldn't be apparent. The scale wouldn't shrink in the way Etana describes. Yet the text captures these details with precision that suggests either remarkable imaginative extrapolation or description of an actual experience. The Sumerian texts also contain detailed descriptions of the Anunnaki's origins. They came, the tablets say, from a place in the heavens. Various translations render this as the planet of crossing or the planet of the passage. Later scholars associated this with Nibiru, a celestial body that supposedly approaches Earth in a long elliptical orbit. But let's look at what else the tablets say about this place of origin. It's described as having a longer year than Earth's, different seasonal patterns, different atmospheric conditions. The texts mention that the Anunnaki required period adjustments when residing on Earth, that Earth's environment wasn't their natural habitat. They're described as preferring certain altitudes, certain temperatures, certain atmospheric compositions. These are oddly specific details to include in mythology. If you're inventing gods from whole cloth, why give them environmental preferences? Why describe them as needing to adjust to Earth's conditions? The level of specificity suggests either very sophisticated myth-making that deliberately creates verisimilitude, or recording of actual information about beings who genuinely came from somewhere with different environmental parameters. The tablets describe construction projects the Anunnaki undertook on Earth. They built cities at specific locations chosen for reasons the texts enumerate: proximity to water sources, access to certain minerals, favorable astronomical sightlines, locations where the bond between heaven and earth was strong, whatever that means. The cities weren't randomly placed. They followed a pattern, a system of geographical relationships that some researchers claim encodes sophisticated geodetic knowledge. In the 1960s, American engineer Morris Chatelain, who worked on NASA's Apollo program, published research examining the geographical relationships between ancient Mesopotamian cities. He found that the cities' positions, when mapped precisely, form geometric patterns, triangles, alignments, proportional relationships. The distances between cities encode mathematical ratios that appear too precise to be coincidental. Mainstream archaeology attributes this to ancient surveying skill, and probably some confirmation bias in finding patterns that aren't really there. But Chatelain, with his engineering background, insisted the precision exceeded what Bronze Age surveying could achieve. The patterns suggested planning at a scale, hundreds of miles across desert and marsh, that seems implausible for a civilization that supposedly lacked sophisticated mapping tools. The descriptions of Anunnaki technology extend beyond flying craft. The tablets mention weapons that produce fire, devices that can see in darkness, tools that could speak across distances. These descriptions could be purely fantastical, or they could be attempts to describe things like flamethrowers, night vision equipment, radio communication using the only vocabulary available to Bronze Age scribes. The Epic of Gilgamesh contains a curious sequence where the hero and his companion Enkidu journey to the cedar forest to confront the demon Humbaba. The text describes Humbaba's defensive capabilities in unusual detail. He possesses 7 splendors, or radiances, that protect him, terrifying weapons that can sense intruders from great distances and strike them down with fire and noise. When Gilgamesh defeats Humbaba and removes these protective devices, the text describes specific procedures: disconnecting power sources, deactivating systems in a particular sequence. This reads less like battling a mythological monster and more like dismantling security equipment. The level of procedural detail is strange for mythology, but would make sense if describing actual technology. Now, mainstream scholars interpret all of this as poetic description of natural phenomena or metaphorical language for political and military power. The divine boats were probably reed ships, or perhaps the sun and moon moving across the sky. The weapons of fire were metaphors for lightning or volcanic eruptions. The detailed procedures were literary devices adding drama to the narrative. These are reasonable interpretations, but they require assuming that ancient peoples, who demonstrated remarkable observational precision in their astronomy and mathematics, somehow became wildly imprecise when describing what they claimed were the most important events in their history: the interactions with beings who allegedly taught them everything. Now, here's where we need to pause and address something important. The popular interpretation of these texts, largely due to Zecharia Sitchin's books in the 1970s and beyond, claims that Nibiru is a real planet on a 3,600-year orbit that brings it periodically into the inner solar system. Sitchin proposed that the Anunnaki came from this planet, that they arrived on Earth approximately 450,000 years ago to mine gold, and that they genetically engineered modern humans to serve as laborers. Mainstream scholars have thoroughly debunked Sitchin's translations and astronomical claims. Professional Assyriologists point out that he frequently mistranslated Sumerian words, sometimes getting basic grammar wrong. Astronomers note that a planet with Nibiru's supposed orbit would be gravitationally unstable and would have been detected by now given our comprehensive sky surveys. NASA has explicitly stated that no such planet exists, that if it did we would have found it decades ago, and that its approach would have caused obvious gravitational perturbations in the orbits of known planets. Let's be specific about Sitchin's errors because understanding where he went wrong is important for understanding why mainstream science dismisses these topics. In his translation of the Enuma Elish, the Babylonian creation epic, Sitchin claimed the text described a collision between Nibiru and a planet called Tiamat, resulting in the formation of Earth and the asteroid belt. He based this on his reading of the Akkadian word, Tiamat, as a planet rather than the primordial sea goddess. But professional Assyriologists point out that Tiamat, in Akkadian texts, consistently refers to salt water, the primordial ocean, chaos in aquatic form. The word appears in countless contexts where it clearly means water, not a planet. Sitchin's interpretation requires ignoring this overwhelming contextual evidence in favor of a reading that supports his predetermined theory. Similarly, Sitchin translated the Sumerian term Anunnaki as those who from heaven to earth came, suggesting extraterrestrial origin. But as we discussed earlier, the actual etymology is Anunnaki, which breaks down as princely offspring or seed of Anu. Every Sumerian dictionary, every linguistic analysis by trained experts confirms this translation. Sitchin appears to have either misunderstood Sumerian grammar or deliberately mistranslated to support his theory. His astronomical claims face even stronger criticism. Sitchin proposed that ancient Sumerians knew about all the planets in our solar system, including Uranus and Neptune, which weren't discovered until the 18th and 19th centuries. He based this on his interpretation of certain seal impressions and artistic depictions that he claimed showed the complete solar system. The most famous example is seal VA 243 from the Vorderasiatisches Museum in Berlin. Sitchin claimed it depicted the sun surrounded by 11 planets, including Nibiru. But archaeologists who specialize in Mesopotamian iconography point out that the seal's imagery follows standard conventions for depicting stars and divine symbols. The central object Sitchin identified as the sun is probably a god or a star deity. The surrounding objects are stars, not planets. Nothing about the seal requires or suggests astronomical interpretation. American astronomer Philip Plait, who has written extensively debunking pseudoscience, analyzed Sitchin's astronomical claims in detail. He pointed out that Nibiru's supposed 3,600-year orbit would make it gravitationally unstable. A planet-sized object on such an elliptical orbit would either be ejected from the solar system or would crash into the sun or another planet within a few million years, a geological eye blink. The solar system is 4.5 billion years old. Nibiru, as described, couldn't have survived that long. Moreover, Nibiru's periodic approaches would cause catastrophic disruptions to the inner planet's orbits. We can measure planetary orbits with extraordinary precision. If a massive object had passed through the inner solar system every 3,600 years for millions of years, the cumulative gravitational effects would be obvious in the orbital mechanics. They're not there. NASA's Near-Earth Object Program tracks thousands of asteroids and monitors for potential impacts. The agency's sky surveys have mapped objects throughout the solar system, from tiny rocks to dwarf planets in the Kuiper Belt. If Nibiru existed and was approaching on its supposed orbit, amateur astronomers with backyard telescopes would have spotted it by now. The idea that NASA could hide a planet-sized object that's supposedly getting close to Earth is absurd given how many independent observers watch the sky. But, and this is crucial, the thoroughness with which Sitchin's specific claims have been debunked doesn't address the underlying questions that make people turn to his theories in the first place. The Sumerian astronomical knowledge is real. The mathematical sophistication is documented. The specificity of Anunnaki descriptions is unusual. The claims of beings from the sky teaching humanity are consistent across thousands of tablets spanning thousands of years. Sitchin provided answers to these questions, even if his answers were built on mistranslations and bad astronomy. Mainstream science has effectively shown that his answers are wrong, but has failed to engage meaningfully with the questions that made those wrong answers appealing. When people ask, how did the Sumerians know about precession? Mainstream archaeology offers vague answers about centuries of observation and inherited knowledge. When people ask, why are the Anunnaki described with such unusual specificity? Mainstream scholars say, that's just how Mesopotamian mythology worked. When people point to sophisticated astronomical content in Bronze Age texts, academics shrug and say, they were smarter than we usually credit ancient peoples. These aren't satisfying answers. They're dismissive answers. They don't engage with the actual historical puzzle. How did a civilization emerge seemingly suddenly with sophisticated astronomy, complex mathematics, and writing systems that were already mature when they first appeared in the archaeological record around 3500 BCE? The mainstream explanation requires us to believe that centuries or millennia of development occurred, but left no archaeological trace. That the Sumerians inherited knowledge from earlier cultures, but we haven't found those cultures. That sophisticated astronomical observation was conducted for generations before writing existed to record it, and somehow that knowledge was transmitted orally with perfect precision across centuries. This is possible. It's certainly more plausible than ancient astronauts, but it requires filling in a lot of gaps with assumptions. And when official institutions refuse to acknowledge that gaps exist, when they dismiss questions as illegitimate simply because someone like Sitchin asked them badly, it creates a vacuum that alternative theories rush to fill. But here's the thing that makes this entire situation so fascinating and frustrating. The dismissal of Sitchin's specific claims doesn't address the underlying question that makes people turn to alternative explanations in the first place. The question that NASA seems unwilling to engage with directly. How did the Sumerians know so much about astronomy? Their knowledge wasn't just impressive for Bronze Age farmers. It was sophisticated in ways that suggest either an inherited tradition of observation spanning many centuries before their civilization emerged, or instruction from an outside source. And when your own texts claim you were taught by beings from the sky, and modern institutions refuse to seriously examine those claims, people begin to wonder what's being hidden. The mathematical mystery. Let's talk about numbers for a moment, because the mathematics in Sumerian texts open another door into this mystery. The Sumerians used a sexagesimal system, base 60 mathematics, rather than the base 10 system most modern cultures use. This is why we still divide hours into 60 minutes and minutes into 60 seconds, why circles contain 360 degrees, why we have 12 inches in a foot and 12 months in a year. These are remnants of Sumerian mathematical conventions that have survived 5,000 years. But why base 60? It's not an obvious choice. Human beings have 10 fingers, which is why most cultures naturally gravitated toward base 10 systems. Base 60 is actually more complex to learn and use, yet it has advantages. 60 is highly divisible, with factors including 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This makes it excellent for astronomical calculations and for dividing time in circles. The Sumerians didn't just use base 60 casually. Their entire mathematical system was built around it, with sophisticated understanding of fractions, multiplication, and division. They could calculate square roots and cube roots. They understood the concept of place value, where the position of a digit determines its value, which was a revolutionary development in mathematics. And they encoded vast periods of cosmic time in their calculations. Numbers like the 432,000-year periods that appear in their creation myths and king lists. Here's an interesting detail that researchers have noted. 432,000 is not just a random large number. It appears to be mathematically significant in ways that suggest deliberate encoding of information. It's 10 times 43,200, and 43,200 is 120 times 360, and 360 is of course related to the degrees in a circle. These numbers interlock in ways that suggest intentional design, a system of proportional relationships that encode astronomical cycles. American astronomer Carl Sagan, in his book Broca's Brain, acknowledged that ancient cultures possessed surprising astronomical knowledge. He suggested that this could be explained by centuries of careful observation and record-keeping, passing knowledge from generation to generation. But Sagan also noted that the precision of some ancient astronomical claims couldn't be easily explained by simple naked-eye observation. Something more sophisticated was happening. NASA's position, when pressed on these matters, typically invokes Sagan's explanation. Ancient peoples were smarter and more observant than we give them credit for. They had centuries to watch the skies and refine their understanding. They developed sophisticated models through trial and error. The apparent gaps in the archaeological record don't mean knowledge appeared from nowhere. They mean we haven't found the evidence of gradual development yet. This is a reasonable position. It's certainly more scientifically defensible than jumping to ancient astronauts as an explanation. But it also feels incomplete, especially when you read the tablets themselves, and notice how the Sumerians consistently attributed their knowledge to specific beings who taught them. They didn't claim to have figured it out themselves through observation. They said they were instructed. And here's where the institutional silence becomes most conspicuous. NASA employs hundreds of historians of science, anthropologists, and archaeologists as consultants and advisors. The agency maintains extensive archives on the history of astronomy and the development of astronomical knowledge. Yet in all of NASA's public communications about the search for extraterrestrial intelligence, in all their educational materials about the history of astronomy, the Sumerian tablets and their claims about the Anunnaki are simply absent, not debunked, not explained, just not mentioned. It's the silence of omission rather than the silence of active suppression. But the effect is the same. The general public remains unaware that humanity's first astronomers said they were taught by visitors from the sky. But wait, what if we're looking at this from the wrong angle entirely? What if the tablets aren't describing literal extraterrestrial visitors, but rather preserving sophisticated astronomical knowledge in mythological language? What if the Anunnaki from the sky were really just the planets themselves, personified as the Sumerians watched them move against the fixed stars? This is actually closer to the mainstream scholarly interpretation, and it has considerable merit. Ancient cultures throughout the world associated planets with gods. The Romans named them after their deities: Mercury, Venus, Mars, Jupiter, Saturn. The Greeks had similar associations. The Babylonians, inheritors of Sumerian astronomy, explicitly linked specific gods with specific planets. In this reading, the stories of Anunnaki descending from heaven describe planetary movements across the sky. The battles between gods might represent conjunctions and oppositions, moments when planets come close together or align in specific patterns. The cycles of return could be sidereal periods, the time it takes for a planet to complete its orbit and return to the same position relative to the stars. This interpretation explains away the astronomical knowledge without requiring outside intervention. The Sumerians were simply very good at observational astronomy, good enough to notice subtle patterns and encode them in their mythology. The tablets are sophisticated astronomical treatises disguised as religious literature. But even this explanation leaves questions. If the Sumerians were this astronomically sophisticated 5,000 years ago, why don't we see clear evidence of the centuries of observation that would have been required to develop such knowledge? The earliest Sumerian cities appear suddenly in the archaeological record around 3500 BCE, already possessing writing, complex mathematics, sophisticated astronomy, and urban civilization. The developmental stages that should precede such achievements are largely absent or poorly documented. The king list and the problem of time. We need to talk about one of the strangest documents to survive from ancient Mesopotamia, the Sumerian king list. This text, preserved on multiple tablets from different periods, purports to record every ruler of ancient Sumer from the moment kingship descended from heaven down to historical times. The list begins with something that makes conventional historians uncomfortable: 8 kings who ruled before a great flood, with reigns lasting tens of thousands of years each. King Ululim of Eridu supposedly ruled for 28,800 years. His successor Alaulgar reigned for 36,000 years. The combined reigns of these 8 antediluvian kings total 241,200 years. Then comes the flood. The text simply states the flood swept over, and after that kingship begins again. But the reign lengths are different. Still long by human standards, the first post-flood king rules for 1,200 years, but nothing like the fantastic numbers from before the deluge. And as the king list progresses through successive dynasties, the reign lengths gradually decrease until they reach normal human lifespans. Mainstream scholars interpret these numbers as mythological, symbolic, or corrupted through copying errors. Some suggest they represent dynasties rather than individual rulers, or that they encode astronomical cycles rather than literal time periods. Others propose that the Sumerians used different time units than we assume, that year might have meant month or some other period, which would reduce the numbers to more plausible ranges. But here's what's curious. The Sumerians were excellent record keepers and precise mathematicians. They used sexagesimal mathematics with clear place value. They understood fractions and large numbers, and they kept detailed astronomical records spanning centuries. These weren't people who got confused about how to count years, or who accidentally wrote 28,800 when they meant 288. The king list exists in multiple copies, created over a span of centuries in different cities. Yet all versions contain the same impossibly long antediluvian reigns. The numbers are internally consistent across these copies, suggesting they were being carefully preserved rather than carelessly invented or corrupted. The scribes who copied these texts, generation after generation, apparently believed the numbers mattered enough to transmit accurately. Some researchers have noted that these antediluvian reign lengths aren't random. They're mathematically significant, often multiples of important numbers in Sumerian cosmology. The number 3,600, called a sar in Sumerian, appears repeatedly. It's worth noting that 3,600 is also the orbital period that Zecharia Sitchin attributed to Nibiru, though this connection requires taking Sitchin's controversial interpretations as valid. What if the king list isn't describing human rulers at all? At least not for the antediluvian period. What if those 8 kings with their impossibly long reigns represent something else? Perhaps celestial cycles, or the reign periods of the Anunnaki themselves before humanity was created, or some other phenomenon that the later Sumerian scribes were trying to preserve without fully understanding. This interpretation would explain why the numbers are so carefully maintained, yet so impossible by normal standards. The scribes inherited these figures from earlier traditions, recognized them as important, and preserved them faithfully, even though they represented something outside normal human experience. And here's where NASA's silence becomes most pointed. The agency has devoted considerable resources to studying long-duration space missions, and the biological effects of extended spaceflight. They understand that humans traveling between star systems would need to either achieve near-light speeds, which introduces time dilation effects, or accept multi-generational journeys. If an advanced civilization visited Earth thousands of years ago, the visitors themselves might have experienced time very differently than the humans they encountered. But NASA doesn't discuss this possibility in relation to ancient texts. They don't address what it might mean if ancient accounts of beings with extended lifespans were describing visitors who had experienced time dilation effects from near-light speed travel, or who came from a world with different gravitational effects on aging, or who possessed life extension technology. The conversation simply doesn't happen in official channels. Instead, we get silence. The agency searches for microbial life on Mars, studies the atmospheres of exoplanets for biosignatures, listens to radio signals from distant stars, but won't engage with humanity's oldest written claims of contact. The disconnect is jarring once you notice it. The warning in the clay. Let's zoom in on something that pops up again and again in Sumerian writing. The idea that disasters aren't just one-off events, they're part of a cycle. The old clay tablets don't just talk about a single, massive flood. They describe repeating patterns, cycles of destruction followed by renewal. According to them, humanity needs to recognize these patterns and get ready when the signs start showing up. The flood story shows up all over Sumerian literature. You see it in the Eridu Genesis, then later in the Akkadian Atrahasis epic, and of course in the flood tale from the Epic of Gilgamesh. But these aren't just stories about beginnings. If you really read them, they sound like warnings. The texts lay out what to look for, how to prepare, what knowledge to save. In the most complete version, the god Enki gives Ziusudra a heads-up about the coming flood. He tells him exactly how to build a boat, dimensions, materials, everything. He says to coat it with bitumen, to load it with pairs of every living thing. These instructions aren't vague or magical, they're surprisingly practical. Somebody knew how to build a boat tough enough to survive a real flood. But here's the catch. The flood isn't some freak once-in-history event. The stories make it clear this kind of thing happens in cycles. The gods, sometimes called the Anunnaki, warn people these disasters follow cosmic patterns. The tablets even hint at astronomical clues, as if you could predict the timing by watching the skies. Modern geology backs this up, at least in part. Archaeologists have dug up layers of silt and flood debris at ancient sites like Ur, Kish, and Shurapak, clear signs of huge floods around 2900 BCE. These weren't global events, but for people living there, they might as well have been the end of the world. The tablets also talk about disasters coming from the sky. They mention strange movements among the stars, cosmic disturbances, and things falling from above, bringing chaos with them. Some texts even describe objects crashing down from the heavens and causing devastation. That lines up pretty well with what scientists now call impact events, asteroids or comets slamming into Earth. We know these have happened all through history, changing the climate, wiping out species, and causing destruction on a massive scale. Take the Younger Dryas impact hypothesis. Scientists think a big asteroid or comet hit Earth about 12,900 years ago, triggering rapid climate change and wiping out a bunch of big animals. They found weird markers in the dirt from that time, nanodiamonds, iridium tiny glass spherules, all over the world. So the Sumerians weren't just making things up. They described real disasters, floods, impacts from space. The real mystery is how they figured out these events follow cycles and could be linked to astronomical observations. These days, NASA takes asteroid threats seriously. They run the Near-Earth Object Program, tracking asteroids and comets that could hit Earth. They've sent missions to check out asteroids up close and have even tested ways to knock dangerous ones off course. The risk is real, and they pour resources into watching the skies. But here's what's weird. When ancient texts mention looming disasters from space, cyclical destruction, or the need to keep knowledge safe through catastrophe, NASA doesn't bring up these ancient warnings. They don't point out that humans have been worrying about cosmic threats since the dawn of writing. Why not? Why doesn't NASA use these old stories to show that our fear of cosmic impacts isn't just sci-fi paranoia, it's ancient wisdom? Why aren't Sumerian tablets part of the conversation? Honestly, the simple answer is probably that digging into these texts means facing everything else they claim. The Anunnaki, the sky beings who supposedly brought these warnings, and the idea that some ancient knowledge came from non-human sources. Once you admit the Sumerians were right about disasters, people will start asking who told them. And that's a can of worms NASA doesn't want to open. But maybe there's another angle. Maybe the Sumerian warnings aren't crystal ball predictions, they're historical records. Maybe they weren't trying to predict the next disaster. Maybe they just wanted to remember the last one. This interpretation has gained traction among some researchers. The antediluvian period with its impossibly long reigning kings might represent pre-catastrophe civilization, perhaps more advanced than what followed. The flood wasn't just water. It was a civilization-ending event that destroyed an earlier society. The Sumerians emerged afterward, inheriting fragments of older knowledge but no longer understanding its full context. In this reading, the tablets aren't warnings given by alien visitors. They're imperfect memories of pre-catastrophe astronomy and engineering, preserved through oral tradition until writing was developed, then finally recorded in clay. The gods who taught humanity were really just the survivors of an earlier human culture, passing down what they could remember of their own civilization's achievements. This explanation has the virtue of not requiring extraterrestrial intervention. It suggests human civilizations might rise and fall in cycles, each learning from fragments left by its predecessors. The Younger Dryas impact or similar event around 12,000 years ago could have destroyed an advanced Paleolithic culture, and the Sumerians 5,000 years ago were still working with echoes of that lost knowledge. But even this interpretation raises questions that NASA's institutional framework struggles to address. If human civilization is cyclical, if we've risen and fallen before, if we're currently rediscovering knowledge that was known and lost in previous ages, that suggests our current technological trajectory isn't unique or inevitable. It implies that what we think of as linear progress might actually be the latest iteration of a repeating pattern. And if advanced human civilizations existed before the Holocene, before the current geological epoch that began around 11,700 years ago, where's the evidence? Where are the ruins, the artifacts, the unmistakable traces that would survive tens of thousands of years? This is where advocates of the lost civilization theory struggle. Absence of evidence isn't evidence of absence, but after decades of archaeological work, we should have found something unequivocal if an advanced civilization existed in deep prehistory. Stone tools and crude artifacts from hundreds of thousands of years ago survive just fine. Why wouldn't the products of a sophisticated culture? The counterargument is that we're not looking in the right places. If such a civilization existed during the last ice age when sea levels were 400 feet lower than today, its coastal cities would now be underwater. The continental shelves that are currently submerged were dry land until about 12,000 years ago. An entire geography of human settlement was drowned by rising seas as the ice sheets melted, and we've barely begun to explore those underwater landscapes. Some underwater archaeological discoveries have fueled speculation. The Yonaguni Monument off Japan, the underwater structures near Bimini, the submerged ruins off the coast of India, all show geometric patterns and right angles that some interpret as artificial construction. Mainstream archaeology typically explains these as natural geological formations that happen to look artificial, but the debate continues. NASA, despite its remote sensing capabilities and orbital imaging technology, hasn't directed resources toward searching for submerged archaeological sites. the agency that can image Mars in incredible detail, that can map the surface of distant moons, hasn't been asked to turn those same technologies toward Earth's continental shelf to search for evidence of lost civilizations. This is perhaps one of the most frustrating aspects of NASA's relationship with alternative history theories. The agency possesses exactly the tools that could definitively answer some of these questions, but institutional mission scope and funding priorities mean those tools are aimed outward at space rather than downward at Earth's mysteries. To be fair, NASA's mandate is space exploration, not underwater archaeology, but the boundary between these domains blurs when we're discussing the possibility of ancient contact. If extraterrestrial visitors came to Earth, they would have left traces. If those traces exist underwater on submerged continental shelves, NASA's imaging technology could potentially detect them. But the research proposals aren't funded, the questions aren't officially asked, and the silence continues. The astronomical alignments. Let's talk about something that really takes Sumerian astronomy to the next level. The insane precision with which ancient builders lined up their temples and monuments with the stars. Most people think of the Egyptians first. The Great Pyramid's sides point almost perfectly to true north, off by just a hair, really. The shafts inside were aimed at specific stars like Orion's Belt and Alpha Draconis. This wasn't just luck or guesswork. It took some serious know-how, both in surveying and in reading the night sky. But honestly, the Sumerians and their Mesopotamian neighbors don't get nearly enough credit for pulling off similar feats. Take the ziggurat at Ur, dedicated to the moon god Nana. Its corners line up with the cardinal directions, and the accuracy rivals what the Egyptians managed. The whole structure is built around mathematical rules, the same ones that show up in their astronomical calculations. Modern archaeologists, armed with GPS and laser tools, have checked out a bunch of these sites. Turns out, many Mesopotamian temples and ziggurats are aligned to the stars and cardinal points with freakish precision. We're talking fractions of a degree. These builders weren't eyeballing it or making rough guesses. They knew exactly what they were doing. Look at the Temple of Shamash in Sippar. When Hormuzd-Rassam dug it up in the 1800s, he found it was built to catch the sunrise on the summer solstice, right on the dot. The priest astronomers there tracked eclipses, followed planetary motions, and kept calendars so accurate they could plan out festivals decades ahead. They even wrote all this down, filling thousands of clay tablets, a gold mine of astronomical records stretching across centuries. And this isn't just a one-off. Across Mesopotamia, Uruk, Nineveh, Babylon, Eridu, temples show the same attention to the sky. Some researchers say that the city layouts themselves mirror the constellations, laying out sacred buildings to match the stars above. It's ambitious, almost poetic. Christopher Knight, an archaeologist and engineer, dug into this idea. He mapped out Mesopotamian cities and claimed he found deliberate geometric links between temple sites. He saw repeating ratios in the distances between major ziggurats. Draw a line between some sacred spots, and it points straight at a key star or solstice sunrise. To him, the whole civilization looked like a giant astronomical machine, with cities and temples as moving parts. Of course, not everyone buys it. Mainstream archaeologists push back, saying you can find patterns in almost anything if you want to, apophenia, they call it. Maybe these alignments are just coincidences, or the result of more practical concerns like water sources and trade routes. Even so, nobody argues with the precision of the buildings themselves. The ziggurats really do line up with the cardinal points. The math built into the temples checks out, and the Sumerians' own records prove they had the astronomical chops to pull it off. Here, where things get really interesting for NASA, the agency has all the gear to test these alignment theories for real. Satellite photos, GPS mapping, software that can show what the sky looked like thousands of years ago. They could settle the debate once and for all. NASA's already used this tech to uncover lost cities in Central America, map ancient canals in the Middle East, even trace the paths of rivers that disappeared ages ago. The tools are there. The experts are there. What's missing is the will to use them to dig into ancient astronomical knowledge, and the possibility that it came from somewhere beyond human tradition. Just imagine a serious NASA-led project. They could scan every Mesopotamian site with LiDAR, mapping them down to the centimeter. They could use computers to rewind the sky, seeing exactly what the stars looked like from Ur or Babylon at any date in history. Algorithms could crunch the numbers and show whether these alignments are just chance, or if the ancients really did build their world as a reflection of the heavens. If such an investigation found nothing significant, if the alignments were within normal variation or could be explained by prosaic factors, that would be scientifically valuable. It would establish baseline knowledge about ancient architectural practices and put to rest unfounded speculation about advanced astronomical encoding. If such an investigation found significant patterns, if the alignments showed astronomical knowledge that conventional chronology couldn't explain, that would be revolutionary. It would force reconsideration of ancient capabilities and might provide evidence for knowledge transmission from earlier, more sophisticated sources. Either outcome would advance understanding. Yet the research doesn't happen. NASA continues searching for life among distant stars while ignoring claims of contact encoded in humanity's oldest architectural monuments. The silence isn't just frustrating, it's scientifically questionable. When anomalous evidence appears, when observations don't fit existing models, the scientific method demands investigation. Not dismissal, not avoidance, not appeals to authority or consensus. Investigation. The Sumerian astronomical texts contain another intriguing element: descriptions of celestial bodies and events that some researchers claim couldn't have been observed with naked-eye astronomy. The MULAPIN tablets mention 12 planets or planetary bodies in their astronomical sections. Most scholars interpret this as referring to the Sun, Moon, and 5 visible planets: Mercury, Venus, Mars, Jupiter, Saturn, plus 5 other bodies that might be bright stars or mathematical constructs rather than actual planets. But alternative researchers point to this as potential evidence that the Sumerians knew about planets beyond Saturn, Uranus, Neptune, and possibly others. Uranus is technically visible to the naked eye under perfect conditions. It's right at the limit of human vision, appearing as a faint star-like point. An exceptionally sharp-eyed observer with a very dark sky might spot it, but recognizing it as a planet rather than a star requires tracking its motion over many nights. There's no clear evidence that ancient observers systematically identified Uranus as distinct from stars. Neptune is definitively invisible without telescopes. No amount of visual acuity or sky darkness makes Neptune visible to unaided human eyes. If the Sumerians knew about Neptune, they learned about it through something other than direct observation. Now, responsible scholarship notes that the MULAPIN tablets don't clearly describe Uranus or Neptune. The 12 celestial bodies mentioned can be accounted for without requiring knowledge of outer planets. Alternative interpretations that claim otherwise are reading more into the texts than is linguistically justified. But, and this is important, the tablets do contain astronomical information that seems beyond the capability of naked-eye observation. They describe the synodic periods of planets, the time between successive similar appearances, like Venus's cycle from evening star to morning star and back, with accuracy requiring decades of systematic observation. They understand that planets follow independent orbital paths rather than being attached to crystalline spheres. They recognize that retrograde motion, when planets appear to move backward against the stars, is a regular, predictable phenomenon. This represents sophisticated astronomical theory, not just empirical observation. Someone understood that planets orbit the Sun or Earth, if you prefer the geocentric model, in a way that creates predictable patterns when viewed from our moving platform. This is non-obvious. It requires mathematical thinking and long-term data collection. American astronomer Bradley Schieffer analyzed ancient astronomical observations from multiple cultures, including Mesopotamian records. He found that the precision of planetary position records from ancient Babylon exceeded what should have been possible with the observational tools we know they possessed. The measurements were too accurate, the calculations too refined. Schieffer proposed that Babylonian astronomers developed mathematical techniques to interpolate between observations, using geometrical methods to calculate planetary positions they couldn't directly measure. This would explain the precision without requiring impossible observational accuracy. But even this explanation raises questions. Developing such mathematical astronomy requires understanding that wouldn't naturally emerge from simple observation. It requires conceptualizing celestial mechanics geometrically, recognizing that apparent planetary motions result from real orbital mechanics, and creating computational methods to model these mechanics precisely. That's not Stone Age astronomy. That's not simple pattern recognition or calendar keeping. That's theoretical astronomy requiring conceptual breakthroughs about the nature of celestial motion. How did it develop so rapidly? The earliest Sumerian cities appear around 3500 BCE. By 3000 BCE, just 500 years later, they have sophisticated astronomical texts recording centuries of observations. This is barely enough time for institutional knowledge to accumulate through normal means, yet the texts suggest far longer observation periods. The conventional explanation invokes earlier, undocumented observation by pre-literate cultures, oral traditions preserving astronomical knowledge until writing was invented to record it. This is plausible but unprovable, and it requires assuming capabilities for pre-literate societies that we have no direct evidence for. The alternative explanation suggests knowledge transfer from a more advanced source. Whether we call that source the Anunnaki, or survivors of an earlier civilization, or something else, the hypothesis is that Sumerian astronomy didn't develop gradually through centuries of observation. It was taught, inherited, transferred from those who already possessed it. This hypothesis makes testable predictions. If Sumerian astronomy was inherited rather than developed, it should show certain characteristics: immediate sophistication without clear developmental stages, knowledge encoded in religious mythological frameworks rather than empirical frameworks, and possible fossil knowledge. Information about phenomena the Sumerians couldn't have observed but which would have been observable from a different location or time period. Some researchers claim these characteristics are present. The astronomical texts do show immediate sophistication. The knowledge is indeed encoded in religious contexts, with planets identified as gods and astronomical events interpreted through mythological narratives. And there are possible examples of fossil knowledge, references to celestial appearances that don't match the Mesopotamian sky in the Sumerian period, but might match earlier positions or different latitudes. But proving this rigorously requires expertise in ancient languages, astronomy, archaeoastronomy, and computational modeling. It requires resources, funding, institutional support. And when the hypothesis being tested involves possible non-human knowledge sources, those resources become very hard to secure. NASA could do this research. The agency employs astronomers, mathematicians, data scientists, and historians of science. NASA has computed retrograde positions of stars and planets for various dates in history for navigation planning and spacecraft targeting. Applying those same computational tools to ancient astronomical texts would be straightforward. Yet it doesn't happen. The expertise exists, the tools exist, the data exists, but the investigation doesn't occur. The questions remain unasked in official venues, left to amateurs and alternative researchers who lack the resources for rigorous analysis. The result is that we don't know. We don't know if Sumerian astronomical texts contain knowledge they couldn't have possessed through their own observations. We don't know if the precision of their calculations suggests teaching from an advanced source. We don't know if the architectural alignments encode information beyond what conventional chronology allows. We don't know because nobody with the proper tools and institutional backing has seriously investigated. And that ignorance, that deliberate ignorance, is itself telling. But the Sumerians left their own architectural astronomy. The ziggurats, those massive stepped pyramids that dominated ancient Mesopotamian cities, weren't just temples. They were precisely oriented structures with astronomical functions. The ziggurat of Ur, one of the best preserved examples, aligns to the cardinal directions with accuracy that required careful celestial observation to achieve. These buildings served as observation platforms. Priests could ascend to the summit and observe the stars, planets, and lunar cycles from above the buildings and dust of the city. The ziggurat's height and clear sightlines made it ideal for tracking celestial objects. The structure itself functioned as a fixed reference point for measuring the sky. The Sumerian temples also incorporated astronomical cycles into their very construction. The number of steps, the dimensions of platforms, the spacing of architectural elements, all encoded mathematical relationships connected to planetary periods and precession cycles. It's as if the buildings themselves were textbooks, preserving astronomical knowledge in stone and brick. This practice of encoding knowledge in architecture appears across ancient cultures. Stonehenge in England, Angkor Wat in Cambodia, Chichen Itza in Mexico, all demonstrate astronomical alignments and mathematical proportions that require sophisticated understanding to design. The global distribution of these aligned structures has led some researchers to propose a lost civilization that spread astronomical knowledge worldwide, though mainstream archaeology prefers to explain this as convergent evolution, different cultures independently developing similar astronomical interests. But here's something remarkable that American researchers have recently documented. Many of these ancient sites align not just to their local celestial phenomena, but to cosmic events that occur on much longer timescales. The precession of the equinoxes, that 25,920-year cycle, appears encoded in monuments from Egypt to Cambodia to Peru. How did separate cultures, with no apparent contact, all decide to encode the same astronomical cycle in their most sacred structures? The mainstream explanation is that careful observation over centuries would eventually reveal precessional motion, and different cultures achieved this understanding independently. The alternative explanation is that they all inherited or were taught this knowledge from a common source, either a lost civilization or, as the tablets suggest, visitors who taught multiple cultures. NASA has the capability to study these alignments in detail. Satellite imaging can measure ancient structures with centimeter-level precision. Computer models can reconstruct exactly what the sky looked like from any location at any point in history, allowing researchers to test claims about astronomical alignments. Some of this work has been done by independent researchers, but it's not a NASA priority. Why not? Why doesn't the agency that sent the Voyager Golden Record into space, a message to potential extraterrestrials containing information about humanity and Earth, have any interest in decoding possible messages that ancient structures might contain? If we assume that advanced civilizations might communicate through long-lasting monuments rather than radio signals, shouldn't we be studying the monuments our own ancestors left to see what they encoded? The silence here is particularly frustrating because this is research NASA could do without controversy. Studying ancient astronomical knowledge and architectural alignments doesn't require taking a position on ancient astronauts or lost civilizations. It's just good science, understanding what earlier humans knew and how they knew it. The fact that this research doesn't happen suggests deliberate avoidance of anything that might accidentally validate alternative theories. But let's examine another possibility. What if NASA's silence isn't about hiding evidence of ancient contact? What if it's about something more prosaic, institutional gatekeeping and paradigm protection? The institutional problem. Here's an uncomfortable truth about how scientific institutions work. They're conservative by nature and by necessity. Paradigms shift slowly because the burden of proof for extraordinary claims is, and should be, extremely high. Carl Sagan famously said, "Extraordinary claims require extraordinary evidence." This principle protects science from being hijacked by every new fringe theory that comes along. NASA operates within this conservative framework. The agency's credibility depends on rigorous adherence to scientific method and evidence-based conclusions. Engaging with ancient astronaut theories, even to debunk them, risks giving those theories undeserved legitimacy. The thinking goes, why dignify pseudoscience with a response? This is a reasonable position with one significant flaw. It assumes ancient astronaut theories are entirely pseudoscientific, with no legitimate questions worth addressing, and that assumption might not be entirely accurate. Let's separate the claims. The idea that extraterrestrials visited Earth thousands of years ago and are encoded in Sumerian texts is extraordinary and currently lacks definitive proof. NASA is right to require extraordinary evidence before accepting this claim. But the observation that ancient cultures possessed sophisticated astronomical knowledge that seems advanced for their supposed technological level, isn't pseudoscience. It's documented fact. The question of how they acquired this knowledge is legitimate. The observation that their own texts attribute this knowledge to non-human teachers is historical record, and the inquiry into whether there might be a connection between ancient astronomical knowledge and the possibility of contact is worth exploring. NASA doesn't need to endorse ancient astronaut theories to acknowledge these questions. The agency could engage with Sumerian texts, acknowledge the sophistication of ancient astronomy, discuss various hypotheses for how that knowledge developed, and explain why the extraterrestrial hypothesis is the least likely explanation based on current evidence. This approach would be educational, scientifically rigorous, and intellectually honest. But that's not what happens. Instead, there's silence. When pressed, NASA officials defer to other disciplines. That's a question for archaeologists, or that's outside our area of expertise. But this deflection ignores NASA's actual expertise in relevant areas. The agency employs astrobiologists who study the possibility of life elsewhere. It funds SETI programs that search for signals from extraterrestrial civilizations. It operates missions to study potentially habitable environments on Mars, Europa, and Enceladus. If we're seriously searching for evidence of extraterrestrial life and intelligence, shouldn't we also examine humanity's oldest written claims of contact? Shouldn't the same rigorous analysis applied to potential microbial fossils in Martian meteorites be applied to ancient texts that describe beings from the sky? The counterargument is that texts aren't physical evidence. They're human interpretation, cultural narrative, mythology. Unlike a fossil or a radio signal, texts can't be objectively analyzed for evidence of non-human origin. Fair enough. But texts can be analyzed for the information they contain, and when that information includes sophisticated astronomical knowledge, it deserves attention. Here's where American institutions have actually made some progress, though not within NASA. In the 1990s, researchers at the University of California studied the astronomical content of ancient texts and monuments. They applied modern computational methods to reconstruct ancient skies and verify claims about celestial alignments. Some of this work validated ancient observations, some debunked exaggerated claims. It was good science, rigorous and evidence-based. But this research happened despite institutional resistance, not because of institutional support. Academics who study these topics risk their reputations and careers. The subjects are tainted by association with pseudoscience, making it difficult to get funding, publish in prestigious journals, or achieve tenure. The institutional structure actively discourages serious inquiry into these areas. And NASA, as perhaps the most prestigious scientific institution in America, sets the tone. When NASA ignores these questions, it signals to other researchers that these aren't respectable topics. The silence cascades through the academic hierarchy, creating a de facto ban on serious inquiry. This is frustrating because the questions are interesting regardless of where they lead. How did ancient cultures develop sophisticated astronomy? What's the earliest evidence of systematic celestial observation? How was astronomical knowledge transmitted across cultures and through time? These are legitimate historical and scientific questions that deserve rigorous study. The fact that ancient texts claim non-human sources for this knowledge doesn't make the questions illegitimate. If anything, it makes them more interesting. Either the texts preserve accurate memories of how knowledge was acquired, in which case we should take them seriously, or they represent cultural mythology about the origins of knowledge, in which case studying them illuminates how ancient peoples thought about learning and wisdom. Either way, there's value in the inquiry. But the inquiry largely doesn't happen, at least not in mainstream institutions. And NASA's silence contributes to that absence. What the tablets actually warn. Let's return to the content of the Sumerian tablets and ask a more focused question. Setting aside who wrote them or where the knowledge came from, what do they actually say? What are the warnings they contain? First and most obviously, they warn about catastrophic floods. Multiple texts describe devastating inundations that destroyed civilization and required starting over from scratch. The specificity of these warnings suggests they're based on actual historical events, whether regional Mesopotamian floods or memories of the post-ice age sea level rise that drowned coastal areas worldwide. Second, they warn about celestial catastrophes. The texts mention objects falling from the sky, fire from heaven, cosmic disruptions that cause earthly destruction. This sounds remarkably like impact events, asteroids or comets colliding with Earth. The Sumerians couldn't have directly observed such impacts during their historical period, or we'd have clear geological evidence. So these warnings likely preserve memories of earlier catastrophes passed down through oral tradition. Third, they warn about cyclical patterns. The tablets don't present catastrophes as random, but as recurring events tied to celestial cycles. Specific astronomical configurations supposedly predict when disasters will occur. This might be sophisticated astronomical knowledge or might be pattern-seeking in random events, but the Sumerians clearly believed catastrophes followed predictable patterns. Fourth, they emphasize the importance of preserving knowledge across catastrophes. The flood hero is instructed to save not just life, but also the arts of civilization, writing, mathematics, astronomy, craftsmanship. The implication is that catastrophes can destroy civilization, but knowledge preserved through disaster allows rebuilding. This suggests the Sumerians understood themselves as rebuilders, carrying forward knowledge from an earlier age. Fifth, they stress the need to watch the skies. Astronomical observation isn't presented as intellectual curiosity, but as practical necessity. Monitoring celestial patterns allows prediction of disasters and preparation for catastrophe. The ziggurats functioned as observation posts precisely because this was considered essential for survival. These are actually sensible warnings based on real threats. Floods, impacts, catastrophe, loss of knowledge. These are genuine risks that civilizations face. The fact that ancient texts emphasize these dangers, even wrapped in mythological language, suggests practical wisdom worth considering. NASA, ironically, agrees with most of these warnings in modern terms. The agency monitors near-Earth objects that might impact our planet. It studies climate change and environmental threats. It recognizes the fragility of complex technological civilization and the importance of preserving knowledge. NASA even maintains the Voyager Golden Records as a way to preserve information about humanity should our civilization collapse. So why doesn't NASA acknowledge that the Sumerians were warning about the same things 5,000 years ago? Why not embrace these ancient texts as humanity's first systematic attempt to identify and prepare for existential risks? The answer might be that making this connection requires engaging with the text's claimed source for these warnings, the Anunnaki. The Sumerians didn't present these insights as their own discoveries. They explicitly attributed them to beings who came from the sky and taught humanity what to watch for and how to prepare. Either this attribution is literally true, extraterrestrial contact, metaphorically true, planets as gods taught lessons through observation, or culturally constructed, mythological origin for knowledge that was actually developed through human effort. But all three interpretations deserve serious consideration, and NASA's silence prevents that consideration from happening in institutional contexts. Let's consider one more possibility, perhaps the most uncomfortable one. What if NASA knows something about these texts that the public doesn't? What if classified research has examined Sumerian astronomical claims and found something that can't be publicly acknowledged? This might sound like conspiracy theory, but consider. NASA does conduct classified research. The agency works closely with military and intelligence organizations. Some satellite data and analytical methods are restricted. It's not implausible that someone, at some point, might have done classified analysis of ancient astronomical texts to see if they contained strategically relevant information. What might such analysis reveal? Perhaps that ancient sky maps show stellar positions from unexpected locations, suggesting either errors in our understanding of stellar proper motion or observation from somewhere other than Earth's surface. Perhaps that certain astronomical predictions in ancient texts were more accurate than chance would allow, suggesting either extremely sophisticated mathematical modeling or access to observational data we can't account for. I'm speculating here. There's no public evidence for classified NASA research on Sumerian texts, but the possibility deserves consideration because it would explain the institutional silence more completely than simple disinterest or paradigm protection. The Nibiru problem. Let's be real. You can't talk about NASA and Sumerian warnings without running straight into the whole Nibiru mess. This supposed planet has turned into a magnet for wild theories and a headache for astronomers everywhere. The story, mainly thanks to Zecharia Sitchin, goes like this. Nibiru is a giant planet with a weird, stretched-out orbit that swings it close to Earth every 3,600 years. Each time it passes, it supposedly wreaks havoc here with its gravity. The Anunnaki, according to the tale, came from Nibiru. So all those ancient warnings about repeating disasters, the theory says they're really about this planet coming back around. NASA's not having any of it. Over and over they've said flat out, Nibiru doesn't exist. No one's seen it, there's no sign of its gravity messing with anything, and if a planet like that really orbited the sun, we'd have noticed ages ago. The guy in charge of NASA's Near-Earth Object Program even called Nibiru an internet hoax, and said there's zero scientific reason to believe in it. Astronomers have their own pile of reasons to roll their eyes at the whole thing. A planet that big, on a wild 3,600-year orbit, it wouldn't stick around. It'd get thrown out of the solar system. If it was coming anywhere near us, it would mess up other planets' orbits in ways we definitely see. Even amateur astronomers with decent backyard telescopes would have spotted it long before it got close. The math just doesn't add up. And then there's the word Nibiru itself. It does show up in Akkadian texts, but the actual meaning is fuzzy. Most experts figure it probably means Jupiter, or maybe just a crossing point in the sky, not some mystery planet lurking beyond Pluto. Professional Assyriologists have gone through Sitchin's translations and shot down his interpretations. So NASA's right to shrug off Nibiru as people describe it today. The specific claims just don't hold water. But here, where things get weird, while NASA laughs off Nibiru, they're also out there hunting for Planet 9, a hypothetical giant planet way out in the solar system. Planet 9 hit the scene in 2016 when some Caltech astronomers noticed strange patterns in the orbits of Kuiper belt objects. The idea is it's a super-Earth, maybe 5 to 10 times heavier than our planet, with an orbit so far out it almost never comes close to the Sun, hundreds of Earth-Sun distances away. Unlike Nibiru, Planet 9's orbit would actually make sense with what we know about gravity. It's a real scientific theory, and serious astronomers are searching for it. Still, you can't help but notice the irony. NASA brushes off ancient claims about a hidden planet, yet they're actively searching for one themselves. Sure, Planet 9 is supposed to be way farther out, and on a much longer orbit than the 3,600-year cycle people talk about with Nibiru. But both ideas involve a big, unseen planet messing with stuff through gravity. Critics love to point this out. Look, you're hunting for undiscovered planets, but you laugh at ancient stories that said the same thing. It's not totally fair. Planet 9 is based on current telescope data, while Nibiru comes from some pretty questionable translations. Still, you can see why people get frustrated, especially if they think scientists dismiss ancient knowledge out of hand. And here's a fun twist. Back in 1983, NASA's infrared astronomical satellite IRAS picked up something odd. There was an infrared signal that looked like it could be a big object way out in the solar system. For a hot minute, news outlets buzzed about a possible 10th planet. Later, scientists figured out it was probably just a distant galaxy, not a planet, and everyone moved on. But that moment shows you, we really do sometimes stumble on weird, unexpected stuff out there. Space is huge. The far reaches of the solar system are basically unexplored, and dark, cold objects are tough to spot. We keep finding new dwarf planets in the Kuiper belt even now. There's still a lot we don't know. So yeah, Nibiru as described in those theories isn't real. But the hunt for unknown worlds in our solar system, that's definitely happening. NASA's all over it. What they won't do is admit that maybe, just maybe, some ancient stories were garbled echoes of real things out there, even if the details got totally mixed up along the way. This double standard drives the alternative crowd nuts. Modern scientists can float the idea of hidden planets based on subtle clues, and that's considered legit. But if ancient people did the same, they're labeled as myth makers. It's all about who's making the claim, not just what the claim actually is. To be fair to NASA, there are good reasons for this differential treatment. Modern astronomical claims are based on direct observational data, perturbations in known objects, gaps in theoretical models, mathematical predictions that can be tested. Ancient claims are based on texts that mix astronomical content with clearly mythological elements, making it difficult to separate potential factual kernels from cultural elaboration. But couldn't NASA address this more constructively? Couldn't the agency acknowledge that ancient texts contain astronomical claims, explain which parts are consistent with modern knowledge and which aren't, discuss what we know about how ancient astronomy developed, and use this as an educational opportunity? Instead, the response is silence or dismissal, and that silence feeds conspiracy theories more effectively than engagement ever would. When authorities refuse to discuss something, people assume there's something to hide. NASA's reticence about ancient astronomical knowledge creates space for speculation that straightforward engagement might prevent. The architecture of watching. ZIGGURATS as cosmic, OBSRVATORAS. Before we jump into NASA's hunt for extraterrestrial life, let's talk about how the Sumerians looked to the skies. They didn't just stargaze for fun. No, they went all in. They built these huge ziggurats, massive stepped pyramids that rose out of the desert, dominating their cities. These weren't just for show. They were real tools for studying the heavens, designed with a level of astronomical know-how that, honestly, makes NASA's silence feel even stranger. Picture yourself standing at the foot of the Great Ziggurat of Ur. Try to wrap your head around what it took to pull this off. 4,000 years ago, people hauled millions of mud bricks to this spot, stacking them into a huge structure that soared more than 60 feet above the sand. It wasn't about decoration or flexing power, though it definitely made a statement. This thing had a purpose. The builders used precise astronomical alignments that took real skill, surveying, math, a deep understanding of the sky. The base of the ziggurat measures about 210 by 150 feet, and it's lined up exactly with the cardinal directions: north, south, east, west. They didn't just eyeball it. They watched the sun, tracked where it rose and set during solstices and equinoxes, and followed the stars, figuring out which ones pointed to true north. The accuracy here isn't an accident. It's the result of careful, systematic observations and real calculation. But there's more. The ziggurat wasn't just lined up with the compass points. It worked as an observation deck. Priests could climb above the dust and rooftops, getting a clear view of the horizon in every direction. From up there, they could track the rising and setting of stars, planets, the sun, and the moon, way more accurately than they ever could from the ground. And wasn't unique. Every major Sumerian city had its own ziggurat. Later on, the Babylonians and Assyrians kept the tradition alive. Take the Enki in Babylon, the famous Tower of Babel. This one was even bigger, reaching about 300 feet high in 7 colored stages. Each color matched one of the 7 classic planets, including the sun and moon: black for Saturn, white for Jupiter, red for Mars, gold for the sun, and so on. Those colors weren't just for looks. They meant something. The color scheme symbolized astronomical knowledge, tying the building itself to the order of the cosmos. As priests climbed the ziggurat, they weren't just going up a building. They were symbolically moving through the planetary spheres, from Earth to the stars. At the very top, they stood at the edge between worlds, perfectly placed to watch the real celestial bodies those colored stages represented. Leonard Woolley, the American archaeologist who dug at in the 1920s and 30s, found that the ziggurat's summit held a small temple or shrine. Ancient texts say these rooms had beds, tables, and fresh food and drink offerings. Officially, these were rest stops for the gods coming down from heaven to visit their earthly homes. But think about it another way. What if those summit rooms weren't mainly for religious rituals? Maybe they were observatories, places where priest astronomers spent the night watching the skies. Those beds, practical, staying up all night to track the stars wears you out. The food and drink kept the watchers going. And it makes sense to put these chambers at the tallest spot in the city, best view in town for sky watching. The architecture backs this up. Lots of ziggurats have built-in sightlines, doorways and walls arranged so you could look right at certain parts of the sky. It's a bit like the sighting tubes on later astronomical tools, letting you measure where things appear in the sky compared to fixed points on the building. The step design wasn't just for looks either. Each level gave a different perspective. Lower levels helped priests measure how high objects were above the horizon. The higher you went, the wider your view of the sky. And the summit, the ultimate observation deck with open views in every direction. The Sumerians even developed a sophisticated system of celestial coordinates for mapping the sky, dividing it into paths or zones. The path of Anu marked the celestial equator and the region around it. The path of Enlil covered the northern celestial regions, while the path of another name for Enki, encompassed the southern sky. These divisions allowed systematic cataloging of stars and planets, with observers noting which celestial objects appeared in which paths at which times of year. This coordinate system required consistent reference points, exactly what the ziggurats provided. An observer at the summit of ziggurat could measure a star's position relative to the horizon, determine which path it occupied, and record this information in clay tablets that would be stored in the temple library below. Over time, generations of observations would accumulate, revealing patterns invisible to any individual observer. The precession of equinoxes, the cycles of planetary motions, the regularities that allowed prediction of eclipses and other celestial events. But here's what makes this particularly relevant to our discussion of NASA's silence. The ziggurats demonstrate that the Sumerians weren't passively receiving astronomical knowledge from hypothetical extraterrestrial visitors. They were actively, systematically observing the sky using sophisticated architectural instruments and mathematical frameworks. Their astronomical knowledge came from centuries of careful work, not from ancient astronauts handing them ready-made star charts. This actually makes their achievement more impressive, not less. They developed sophisticated astronomy through human ingenuity and persistent observation. They encoded that knowledge in architectural monuments that served both practical and symbolic functions. They created institutions, the temple priesthoods, dedicated to maintaining astronomical observations across generations. Yet this human achievement doesn't resolve the central mystery. Because while the ziggurats explain how the Sumerians conducted astronomical observation, they don't fully explain where their initial knowledge framework came from. Building a ziggurat requires already understanding that astronomical observation is important, already possessing mathematical concepts for measuring and mapping the sky, already having a coordinate system for organizing celestial data. The architectural instruments presuppose the knowledge they were built to gather. It's like finding a sophisticated telescope in a culture that supposedly had just discovered optics. The telescope proves they were doing serious astronomy, but it also raises questions about how they developed the theoretical framework and technical expertise to build such an instrument in the first place. The Sumerian texts themselves attribute this framework to the Anunnaki, claiming these beings established the first temples, taught the measuring of the heavens, and set humanity on the path of systematic skywatching. Whether this attribution is literally true, mythologically constructed, or some complex mixture of both, it represents the Sumerians' own understanding of their astronomical tradition's origins. And NASA, despite possessing exactly the kind of expertise needed to analyze ancient astronomical practices and instruments, maintains its silence. The agency that operates the most sophisticated astronomical instruments ever built, space telescopes that can peer billions of light years into the cosmos, has nothing to say about humanity's first astronomical instruments and the knowledge traditions they embodied. You'd think NASA would embrace the ziggurats as part of humanity's astronomical heritage. The agency could use these ancient structures as powerful symbols in public outreach. For 5,000 years, humans have built instruments to study the heavens. From ziggurats to space telescopes, our species has always looked up and wondered. This would be inspiring, uncontroversial, and true. But making that connection would require acknowledging what the Sumerians said about their astronomical knowledge, that it came from beings who descended from the sky. And that acknowledgement, apparently, is a bridge too far for institutional science. The mathematical language of the cosmos. Sumerian mathematics isn't just some ancient curiosity. It's a window into a whole way of thinking that most people never hear about, partly because organizations like NASA don't talk about it much. The numbers themselves have stories to tell. Take the Sumerian base 60 system. They didn't pick it randomly. Base 60 is actually fantastic for astronomy. 60 divides easily by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, which makes working with fractions a breeze. That's a big deal when you're dividing circles, mapping the sky, tracking how long things take to move, or just doing complex math about planets and stars. And look at us, we still use base 60 every day. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. All of that comes from the Sumerians. We kept their math for things like time and angles because, frankly, nothing else works better. After 5,000 years, nobody found a reason to change it. That's not a coincidence. It's proof that their system was designed for exactly these jobs, and it's still the best tool we've got. But the Sumerians didn't stop there. Their clay tablets show they understood place value, the idea that a number's position changes its value. They could handle gigantic numbers and tiny fractions. They knew geometry and even had formulas for area and volume that match what you'd find in a modern classroom. They worked out approximations for things like the square root of 2, and they got surprisingly close. Otto Neugebauer, an American mathematician who basically started the modern study of ancient math and astronomy, was blown away by how advanced the Babylonians, who built on Sumerian math, really were. He pointed out that their methods for predicting where planets would be were, in some ways, even smoother than the geometric models that Europe used until the Renaissance. There's something else wild in those tablets, the way the Sumerians wrote about huge spans of time. When they said a king ruled for 28,800 years, that wasn't a mistake or a myth. They wrote it out in base 60 as 800, which means 8 times 60 squared. These weren't sloppy legends. They were precise, mathematical ways to express enormous numbers. So what do these huge numbers actually mean? They probably weren't talking about literal human lifespans. Maybe they were encoding astronomical cycles. That number 432,000 pops up all over Sumerian records. If you divide 432,000 by the length of the precessional cycle, about 25,920 years, you get roughly 16.67, close to 50 divided by 3. Not a perfect fit, but it suggests they were thinking in cycles, not years. Or maybe, if you take the old texts at face value, these numbers are about the Anunnaki, beings who supposedly experience time differently. If they traveled near the speed of light or came from a world with a different year, their years wouldn't match ours at all. Those massive reigns might make sense in some other frame of reference. I'm not saying ancient astronauts were real. The point is, these numbers and methods are complex enough to support a lot of different interpretations. They deserve real investigation. NASA has mathematicians and astronomers who could dig into this, test the math, and maybe tell us what the Sumerians were really getting at. But that's not happening. NASA and the big scientific institutions stay silent. Instead, it's independent researchers and a few academics, people working on the fringes, usually without much funding, who try to unravel these mysteries. Now look at how NASA searches for extraterrestrial life today. They fund SETI, scanning the sky with radio telescopes for alien signals. Kepler and TESS have found thousands of planets, some of them potentially habitable. The James Webb Space Telescope checks the atmospheres of distant worlds, looking for hints of life in the chemistry. This is top-tier science, with serious money and respect behind it. NASA and mainstream astronomers are committed to the search for life beyond Earth. Pretty much everyone in the field agrees that life elsewhere is likely, and that intelligent life could be common. Nobody's laughing this off. The search is real, and the motivation is strong. But notice what this search assumes, that we need to look outward to find evidence of extraterrestrial intelligence, that we need to scan distant stars for radio signals, analyze light from exoplanets for signs of life, send probes to Mars and Europa and Titan. The assumption is that evidence of contact, if it exists, will be found in space or on other worlds. What if that assumption is wrong? What if the evidence is here, on Earth, in our museums and archaeological sites and ancient texts? What if we're looking billions of miles away for something that already visited thousands of years ago? This isn't to say that current searches should stop. Even if ancient contact occurred, that doesn't mean extraterrestrial life isn't currently out there to be found. But it does suggest that the search might be incomplete. We're looking for evidence where we expect to find it rather than where it might actually exist. Consider the resources devoted to each approach. NASA's astrobiology budget runs hundreds of millions of dollars annually. SETI receives significant private funding. Space missions cost billions. Yet funding for rigorous archaeological and historical research into ancient astronomical knowledge is tiny by comparison. It's mostly done by underfunded academics or self-funded independent researchers. This imbalance reveals an institutional bias. Evidence in space is taken seriously. Evidence in ancient texts is not. The bias might be justified if ancient texts had nothing interesting to say. But as we've explored tonight, they contain sophisticated astronomical knowledge, detailed warnings about cosmic catastrophes, and explicit claims of contact with non-human intelligence. Whether those claims are literally true or not, they deserve serious investigation. American universities have occasionally undertaken such research. The University of California's archaeoastronomy programs have studied ancient astronomical knowledge. Harvard's Department of Astronomy has analyzed possible alignments in ancient structures. Some scholars take these questions seriously, but they work at the margins of their disciplines, often facing skepticism or hostility from colleagues who view these topics as fringe. NASA could change this landscape simply by directing some attention and resources toward these questions. The agency's imprimatur would legitimize research that currently struggles for funding and respect. Even if NASA's conclusion was ultimately skeptical, that ancient astronomical knowledge developed through human observation, without outside assistance, the process of reaching that conclusion rigorously would advance our understanding of history and science. But that doesn't happen, and we're left to wonder why. Why is an agency dedicated to searching for life beyond Earth so uninterested in examining humanity's oldest claims of contact with beings from the sky? Let's consider the most charitable interpretation. NASA focuses on questions it has the tools to answer. The agency does space exploration and astronomy, not archaeology and linguistics. Sumerian tablets are outside NASA's core competency, so it's appropriate to leave those questions to historians and archaeologists. This explanation has merit. Institutional specialization is sensible. NASA shouldn't try to do everything. But the boundary between astronomy and archaeoastronomy isn't as clear as this suggests. Ancient astronomical knowledge is directly relevant to understanding how astronomical science developed. Historical claims about celestial phenomena can be tested using modern astronomical tools. NASA has both the expertise and the technology to contribute to these questions. Moreover, NASA doesn't strictly limit itself to space science. The agency studies Earth's climate, operates weather satellites, monitors natural disasters, and even studies human factors like how isolation affects astronaut psychology. These are all outside the strict definition of space exploration, but within NASA's broader mission of using space-based tools to advance knowledge. So the disciplinary boundary argument doesn't fully explain the silence. NASA stretches its mandate in many directions, but not toward ancient astronomical texts. The choice seems deliberate rather than incidental. Perhaps the real issue is risk management. NASA depends on public funding and congressional support. The agency has to maintain credibility with both scientists and the general public. Engaging with ancient astronaut theories, even critically, risks that credibility. The potential downside, being accused of validating pseudoscience, might outweigh any benefit from clarifying these issues. This would be a pragmatic reason for silence, but it's also depressing because it suggests institutional cowardice. It implies NASA would rather avoid uncomfortable questions than address them honestly, would rather maintain comfortable silence than risk controversy. And silence, as we've discussed, creates its own problems. It allows misinformation to flourish. It prevents rigorous analysis of actually interesting historical questions. It makes people suspicious that something is being hidden. NASA's silence about Sumerian astronomical knowledge might be more damaging to the agency's credibility than engagement would be. The alternative explanation. Throughout this journey, we've examined NASA's silence from multiple angles. We've considered institutional conservatism, paradigm protection, disciplinary boundaries, risk management. But let's entertain one more possibility that we've touched on but not fully explored. What if the silence isn't about hiding evidence of ancient astronauts, but about protecting something else entirely? What if NASA's reluctance to engage with Sumerian texts is about protecting humanity from knowledge, we're not ready to handle. This sounds melodramatic, but consider what widespread acceptance of ancient contact would actually mean. It would fundamentally alter humanity's self-understanding. We would no longer be the products of unguided evolution and cultural development. Our civilizations would be revealed as influenced, shaped, perhaps even created by outside forces. The religions, philosophies, and self-concepts that have defined human culture for millennia would require complete revision. Such a revelation could be psychologically and socially destabilizing. History shows that civilizations often struggle when their fundamental beliefs are overturned. The impact of European contact on indigenous American cultures provides a sobering example. Entire worldviews collapsed, leading to social disintegration that persists centuries later. If NASA or other government agencies have evidence suggesting ancient contact actually occurred, revealing that evidence carelessly could trigger similar social upheaval globally. The careful, conservative approach would be to maintain silence until humanity is socially and psychologically prepared for the revelation. This is, of course, pure speculation. There's no public evidence that NASA possesses secret information about ancient contact, but the speculation illustrates an important point. Silence doesn't necessarily indicate conspiracy or cover-up. Sometimes institutions remain silent about topics because addressing them would cause more problems than it solves. But even if we accept this charitable interpretation, it raises ethical questions. Do institutions have the right to decide what information humanity is ready to handle? Doesn't democratic society require transparency and informed consent? If NASA or government agencies possess evidence relevant to humanity's origins and history, don't we have a right to know? These questions don't have easy answers. The tension between transparency and stability, between information and social cohesion, is real. But in a democratic society, the default should be openness. Claims that people can't handle the truth often serve as cover for less noble motivations. And frankly, I suspect humanity is more resilient than institutional gatekeepers give us credit for. We've adapted to countless paradigm shifts already. Learning that ancient contact occurred would be shocking but not necessarily catastrophic. People might even find it exciting, opening new avenues of inquiry and self-understanding. So even if NASA's silence is motivated by protective instincts rather than malice or conspiracy, those instincts might be misguided. We might be better served by open, honest engagement with these questions than by paternalistic silence. But let's return to solid ground. We've speculated extensively, perhaps too extensively. What do we actually know? We know the Sumerian tablets exist. They're real artifacts containing real text, written by real ancient people. We know these tablets describe sophisticated astronomical knowledge. Professional Assyriologists who study these texts acknowledge the astronomy is impressive for the Bronze Age. We know the tablets explicitly claim this knowledge came from beings called the Anunnaki who descended from the sky. We know NASA searches for extraterrestrial life and intelligence. The agency devotes substantial resources to this search, examining distant planets, listening for radio signals, studying the possibility of life in our own solar system. We know NASA has the tools and expertise to analyze ancient astronomical claims rigorously. And we know NASA chooses not to do this, maintaining silence when asked about ancient texts' astronomical content and claims of contact. That's what we know. Everything else, the reasons for NASA's silence, the accuracy of Sumerian astronomical knowledge, the reality or non-reality of ancient contact, remains uncertain, open to interpretation and ongoing investigation. What we can say with confidence is that interesting questions exist at this intersection of ancient texts and modern astronomy. These questions deserve serious attention from our best scientific institutions. Whether that attention ultimately validates or debunks alternative theories is less important than the fact that rigorous inquiry would advance our understanding either way. And that inquiry largely isn't happening. That's the real mystery at the heart of this story. Not whether ancient astronauts visited Earth, but why modern institutions are so reluctant to investigate the question seriously. The cosmic context. Let's step back for a second. Humanity's barely out of diapers, cosmically speaking. We've sent a dozen people to the moon, and that was over 50 years ago. Our most ambitious explorers now are robots, drifting around the solar system but never leaving it. Even Voyager 1, the furthest out we've ever flung a piece of ourselves, is just now slipping out of the sun's reach after nearly half a century. At the pace it's going, reaching the nearest star would take it about 70,000 years. So yeah, we're basically stuck at home. We're stuck on Earth, tied to our solar system, completely cut off from whatever or whoever might be out there. People call this cosmic quarantine, the idea that the sheer scale of space keeps civilizations like ours isolated. The stars are just too far apart for us to bridge the gap, at least with the tech we've got. But what if this quarantine wasn't always so airtight? Maybe, long ago, hopping between stars was easier, or maybe some civilizations out there aren't stuck crawling at sublight speeds like we are. What if ancient stories, like those on Sumerian tablets, actually remember a time when Earth wasn't so alone? Maybe there was a window when the quarantine lifted and things got interesting. That's where the Fermi paradox comes in. Fermi's big question was, where is everybody? If the galaxy's full of life and civilizations have had billions of years to expand, why don't we see any signs of them? Why does it feel like we're shouting into a void? People have tossed out all sorts of answers. Maybe life's rare. Maybe civilizations snuff themselves out before they go interstellar. Maybe the galaxy's full of quiet types who stay hidden from newcomers like us. Or maybe nobody bothers with interstellar travel because it's just too tough. Or maybe we're being kept in a sort of preserve, left alone on purpose, like animals in a wildlife sanctuary. But here, another idea. Maybe we already found evidence of visitors, only we don't recognize it. Maybe it's buried in old stories and monuments. What if ancient cultures really did record contact, and modern science just refuses to see it because it doesn't fit the official narrative? If that's true, then the Fermi paradox isn't much of a paradox. We're not alone, and we're not unvisited. Maybe we're just in a quiet stretch, left to our own devices after some early contact. Honestly, this way of looking at things makes some parts of history easier to understand. Why did civilization suddenly pop up in different places? Mesopotamia, Egypt, the Indus Valley, around the same time a few thousand years ago. Why do those early cultures share things like big stone buildings, advanced astronomy, writing, and complex societies? Sure, the mainstream answer is that people just come up with similar solutions to similar problems. But maybe there was some outside influence, whether from another group of humans or, well, someone not from around here. NASA and SETI focus on finding aliens who are out there right now, hopping to catch a signal or maybe someday send a message. But if someone visited thousands of years ago and moved on, we're not going to hear from them over the radio. If that happened, we should be looking at history, not just the stars. SETI researchers have started to realize this. Some now talk about archaeological SETI, looking for ancient artifacts left behind, not just listening for beeps from the next star over. Maybe there's something on the moon, an artifact that could last forever in all that airless dust. Or maybe there's a weird chemical signature here on Earth, a trace of ancient technology. These aren't fringe ideas, they're real directions in SETI research. They admit that contact might have happened already, not just in some distant future. But here's what's strange. When ancient texts straight up describe contact, scientists usually write them off as myths. That double standard is annoying. Maybe it's all about evidence. Physical stuff, an alien tool, a spaceship, something left on the moon would be hard to argue with. Stories and ancient texts. People can always call them legends or misunderstandings. For extraordinary claims, scientists want extraordinary evidence. Fair enough. So where's the proof? If beings like the Anunnaki really visited ancient Mesopotamia and jump-started civilization, where's the hardware? Where are the tools, the ships, the clear traces that would settle the argument once and for all? The honest answer is that no such artifacts have been definitively identified. Some researchers point to out-of-place artifacts, objects that seem technologically advanced for their supposed age, like the Antikythera mechanism or precision-cut stones in megalithic architecture. But these can usually be explained as impressive human achievements rather than alien technology. Humans are clever and have been for a very long time. Sophisticated constructions don't require outside assistance. The absence of unambiguous physical evidence is the strongest argument against ancient contact. If visitors came, they left no trace except in texts and maybe in transmitted knowledge. This seems unlikely if the contact was extensive and included things like construction projects or mining operations, as some theories suggest. However, absence of evidence isn't evidence of absence. The archaeological record is incomplete. Most of what existed in the past has been destroyed by time, weathering, recycling of materials, and natural processes. What survives is a tiny fraction, preserved by chance. If ancient visitors deliberately removed evidence when they departed, or if their technology was organic biological rather than metal and stone, little would remain after thousands of years. Also, we might not recognize evidence even if we found it. If visiting technology was sufficiently advanced, it might not resemble our expectations. We look for metal spacecraft and electronic devices because that's what we would build. A civilization thousands or millions of years ahead of us might use technologies based on principles we don't yet understand. Their artifacts might look like natural objects to our untrained eyes. This isn't special pleading to preserve a theory against contrary evidence. It's acknowledging the limits of our knowledge and observational capabilities. But it also shows how unfalsifiable the ancient astronaut hypothesis can become. If no evidence is found, advocates can always claim it was removed, or we're not looking in the right places, or we wouldn't recognize it if we found it. This unfalsifiability is a weakness of the hypothesis. Good scientific theories make specific predictions that can be tested and potentially proven wrong. Ancient astronaut theories tend to be flexible enough to accommodate any evidence or lack thereof, which makes them less useful scientifically. But let's return to NASA's role. Even if ancient contact didn't occur, the Sumerian texts contain impressive astronomical knowledge. That knowledge deserves study regardless of its source. Understanding how ancient peoples observed and conceptualized the cosmos is valuable in itself. NASA could contribute to this understanding without taking any position on ancient astronauts. The agency could fund research into ancient astronomy, support the development of better tools for analyzing historical astronomical claims, partner with archaeologists and historians to understand the development of astronomical knowledge across cultures. This would be good science, good history, and good public outreach. It would demonstrate that NASA values the long history of human engagement with the cosmos. But it doesn't happen, and we're left wondering why a space agency isn't interested in the history of humanity's relationship with space. The uncomfortable questions remain. As we approach the end of this exploration, let's acknowledge what we haven't resolved. We haven't definitively explained how the Sumerians acquired their astronomical knowledge. We haven't proven or disproven ancient contact. We haven't fully explained NASA's institutional silence. These questions remain open, awaiting future research and evidence. But we have illuminated the landscape of this mystery. We've seen that real puzzles exist at the intersection of ancient texts and modern astronomy. We've examined the institutional dynamics that discourage serious investigation of these puzzles. We've considered multiple explanations, from the mundane to the extraordinary, and found each wanting in different ways. The truth, whatever it is, likely sits somewhere in the complex middle ground. The Sumerians probably acquired their knowledge through careful observation over time, combined with inherited wisdom from earlier cultures, influenced by cultural mythology about its origins, and encoded in symbolic language that makes interpretation difficult. Ancient contact might not have occurred, but ancient people's own interpretations of their knowledge sources deserve respect and attention rather than dismissal. NASA's silence probably reflects institutional conservatism and risk aversion rather than conspiracy or cover-up. But that silence has consequences, creating space for speculation and conspiracy theories that more open engagement might prevent. The agency serves the public and has a responsibility to address questions that public finds important, even when those questions involve non-mainstream ideas. As for the Anunnaki themselves, whether they were extraterrestrial visitors, mythologized planets, cultural constructs explaining the origins of knowledge, or something else entirely, we may never know with certainty. The evidence is ambiguous, open to multiple interpretations, unlikely to be definitively resolved without new discoveries that change the landscape of what we know. But the journey has value even without a destination. Asking these questions, examining ancient texts seriously, considering alternative explanations while maintaining critical thinking, refusing to accept easy answers from either mainstream or alternative sources. This is how we advance understanding. The Sumerian tablets will continue to sit in museums, their cuneiform characters as clear today as when they were first pressed into clay. They'll continue to tell their stories of cosmic cycles, celestial visitors, divine knowledge gifted to humanity. And scholars will continue to debate what those stories mean, where that knowledge came from, whether we should take these ancient claims seriously. NASA will continue to search the skies for signs of life, listening to distant stars, analyzing alien atmospheres, hoping to answer the age-old question, are we alone? And the irony will persist. Humanity's oldest answer to that question, preserved in our first written texts, remains unexamined by the very institution most dedicated to asking it. Perhaps that will change. Perhaps new evidence will emerge from archaeological discoveries, from advances in translating and interpreting ancient texts, from space missions that find something unexpected. Perhaps institutional attitudes will shift as older paradigms give way to new generations of researchers with different assumptions. Or perhaps the silence will continue. Perhaps these questions will remain at the margins, investigated by independent researchers and alternative scholars while mainstream institutions focus elsewhere. Perhaps the mysteries of ancient Sumerian astronomy and the claims about the Anunnaki will never receive the serious, well-funded, rigorous investigation they deserve. Either way, the questions remain, and they're worth asking, even if we never find satisfying answers. Because the process of inquiry itself, of looking at our past with fresh eyes, of taking ancient peoples seriously as observers and thinkers, of recognizing that our modern knowledge might be less complete than we imagine, that process has value. The Sumerians, sitting by their rivers 5,000 years ago, pressing reeds into clay to preserve what they knew and what they'd been told, were engaged in the same fundamental human project we continue today. Trying to understand our place in the cosmos, our relationship to the sky, our origins and our destiny. They looked up at the stars and saw patterns. They tracked those patterns with impressive precision. They encoded that knowledge in mathematics and mythology. They passed it down through generations, believing it was important enough to preserve through whatever catastrophes might come. And then, when writing was invented, they inscribed it all in clay. Not because anyone told them to, not because they were following some ancient astronaut instruction manual, but because humans do this. We observe, we wonder, we record, we share. It's what makes us human. Whether the Anunnaki were real visitors or mythological constructs, doesn't change the fundamentally human act of looking at the sky and trying to understand it. Doesn't change the achievement of developing sophisticated astronomy with nothing but naked eyes and patient observation. Doesn't change the wisdom of warning future generations about cosmic dangers and cyclical catastrophes. The tablets deserve respect for what they are. Humanity's first attempts to write down what we knew and what we feared and what we hoped. They deserve serious study, not because they necessarily contain evidence of ancient astronauts, but because they represent the beginning of humanity's long conversation with the cosmos. And NASA, as the modern institution continuing that conversation, should acknowledge its origins, should recognize that the search for extraterrestrial intelligence didn't begin with radio telescopes and space probes. It began when ancient peoples looked at the sky and asked, "What's out there? Are we alone? Has anyone visited us?" Those are the same questions NASA asks today. The tools and methods have changed dramatically, but the fundamental inquiry remains constant. We're all still looking up, still wondering, still hoping to understand our place among the stars. The silence about ancient texts and ancient claims doesn't serve that inquiry well. It creates artificial boundaries, dividing respectable questions from fringe ones, modern science from ancient wisdom, what we're allowed to wonder about from what we're not. But truth doesn't respect such boundaries. Understanding comes from following questions wherever they lead, even when they lead to uncomfortable places, even when they challenge paradigms, even when they require taking seriously what institutions would prefer to dismiss. The final whisper of clay. We're back where we started, standing in that dim museum archive, holding the clay tablet in your hands. You feel the weight of it, the cool surface etched with wedge-shaped marks, each one pressed into wet clay 5,000 years ago. It's not just writing. It's the trace of a real person, living in a world long gone, trying to say something that mattered. Think about how many hands protected this little slab, through wars, floods, dynasties, disasters, while so much else vanished. That Sumerian scribe is dust now. The priests, the temples, the cities, they're all gone. The canals are choked with silt, the ziggurats just piles of brick. Everything fell apart. Everything except what mattered most. The message itself survived. The knowledge, the warning. That's the real takeaway, honestly. Not whether the Anunnaki showed up, or if NASA's got some secret files stashed away, or if ancient astronauts ever really landed on Earth. What matters is this: people fought to keep their knowledge alive. They wrote it down, hid it, saved it, passed it along, even as their world fell apart. They wouldn't let their truths get lost. The Sumerians believed in the importance of what they recorded. They wanted someone someday to know what they knew. Maybe they were writing about gods from the sky, or maybe they were just chronicling the stars they watched night after night. Either way, they pulled it off. We're still reading their stories, still puzzling over their astronomy, still chewing on their questions. The tablets did what they were meant to do. So when you close your eyes tonight, let your mind wander. Somewhere under Iraq's sand, more tablets wait, holding on to knowledge, warnings, and clues about who we are and where we came from. There are people out there, at NASA, in labs and universities, who could help make sense of all this. They have the tools, the training, the curiosity. They could tell us what the Sumerians really knew about the sky, about visitors, about the universe. But they don't, they stay quiet. Maybe tomorrow they'll speak up. Maybe we'll find new evidence, get new answers, finally take these old questions seriously. Maybe we'll connect the dots between ancient stories and modern searches for life beyond Earth. Or maybe the mystery just keeps growing. Maybe we'll realize the Sumerians were even wiser than we thought. Maybe their warnings about cycles and cosmic dangers hit closer to home than we'd like. Either way, the tablets keep waiting. They've made it this far. They'll wait as long as they have to, holding their secrets for whoever's ready to listen. So sleep easy, knowing you're part of this endless line of thinkers and questioners. You share something with those old Sumerians, the urge to look up, to wonder, to write things down so they aren't forgotten. Tonight, the Sumerians reached across time and spoke to you. Their words survived. Their questions are still hanging in the air. Where did we come from? Are we alone? What's out there in the dark? And tomorrow, NASA will go on scanning distant stars, maybe missing the answers already pressed into clay by the first writers. There's a kind of poetry in that. It isn't silence, though, not really. Because the tablets are still here, the questions haven't gone anywhere. Sooner or later, someone will listen. Maybe it'll be you. Maybe it'll be tomorrow. Maybe it'll take another disaster for us to finally pay attention. Until then, rest. Dream about those ancient skis and the clay that remembers. Picture the scribes working late by lamplight, writing down things they didn't fully understand but knew were important. Civilizations come and go, but the stars just keep on turning. And when you wake up, who knows? Maybe you'll see the sky differently. Maybe you'll wonder what the ancients saw and why we don't look harder at what they left behind. Maybe you'll decide to join in and keep this 5,000-year-old conversation going. Or maybe you'll just remember that once, long ago, people looked up at the same stars you see and wondered the same things you wonder. And they wrote it all down, hoping someone in the future would understand. They were talking to you. The question is, are you ready to listen? But what if we've been looking at this entire mystery from the wrong angle? What if the question isn't whether NASA believes the Sumerian tablets, but whether NASA can afford to acknowledge what they might imply? Think about it for a moment. Imagine you're sitting in a NASA boardroom, surrounded by engineers and scientists whose careers depend on maintaining institutional credibility. Someone suggests dedicating resources to studying ancient Mesopotamian texts for evidence of extraterrestrial contact. The room goes silent, not because the idea is ridiculous, but because engaging with it publicly would open floodgates that no one knows how to close. The tablets themselves don't care about our institutional anxieties. They sit in climate-controlled archives, their cuneiform characters as legible today as when they were first pressed into clay. The British Museum holds thousands of them. The University of Pennsylvania Museum has entire rooms filled with Sumerian artifacts. The Iraq Museum in Baghdad, despite decades of conflict and the tragic looting of 2003, still preserves countless tablets that have never been fully translated or studied. Each tablet is a time capsule, a message in a bottle thrown across an ocean of 5,000 years. And we're standing on the shore, finding these bottles one by one, reading their messages with a mixture of fascination and discomfort. The untranslated archive. Here, something you might not expect. After more than 100 years of digging and deciphering, there are still tens of thousands of Sumerian and Akkadian tablets sitting in museum basements, untouched and untranslated. They're all neatly cataloged, but no one really knows what's inside. The truth is, Assyriology isn't a big field. It's underfunded, the experts are getting older, and there just aren't enough new people coming in to keep up with all the material still coming out of the ground. So what's on these tablets anyway? Most of them probably cover the usual ancient paperwork, grain receipts, tax rolls, arguments over land. But buried in that mountain of clay, there could be astronomical records no one's seen before, myths that never made it into the textbooks, or new details about the Anunnaki that could upend what we think we know. It wasn't always like this. American universities used to dominate Mesopotamian archaeology. The Oriental Institute in Chicago, Penn's Museum, Harvard's Semitic Museum. They ran big digs in Iraq 100 years ago and shipped thousands of artifacts home. Now, most of those tablets are packed away in storage, collecting dust. The money dried up. These days, when budgets get handed out, Mars missions and exoplanet research get the spotlight. Not many people want to learn cuneiform, and the few specialists left are heading toward retirement. The expertise that took generations to build is fading, and not much is being done to replace it. Here's the weird part. We have more Sumerian texts at our fingertips than ever before, but fewer people who can actually read them. We've got the tech to take perfect photos of every tablet, build huge digital archives, even use AI to help crack the code. But the funding never shows up, priorities drift elsewhere, and the tablets just sit there, silent as ever. NASA could change all this without even noticing the cost. They spend billions every year exploring space. Throw a few million at digitizing and translating ancient astronomical texts, and you'd barely see it on their balance sheet. The payoff could be massive. Either we confirm that ancient astronomers figured things out on their own, or we stumble onto something that changes our whole understanding of how knowledge moved around in the ancient world. But nobody really connects NASA's work to these old tablets. The agency searching for life in the universe isn't signing up to help us decode what our ancestors thought about visitors from the sky. The gap stays wide, and the tablets remain unread. Just think for a second. What if we actually tried? What if NASA teamed up with universities to create a massive digital archive of every Mesopotamian astronomical text? Imagine machine learning tearing through thousands of tablets, spotting patterns and links we'd never see on our own. The same computing muscle we use to search for exoplanets could unlock secrets hidden in 5,000-year-old clay. Maybe we'd find that Sumerian astronomy was way ahead of its time. Maybe repeated details about the Anunnaki would turn out to be more than just stories. Maybe there's a system behind them. Or maybe the ancients had clever ways of encoding information, buried in math or language, that we've totally missed. Or honestly, maybe we just confirm that Sumerian science, while amazing, fits right into the normal flow of human discovery. Maybe we'd finally put to rest all the wild alternate theories, not by ignoring them, but by actually checking the data and seeing what holds up. Either way, we'd learn something. Either way, we'd move forward. But we don't, because the people with the power to change things aren't interested. Because it's safer to leave the mystery alone than to risk rocking the boat. The tablets don't care. They've already waited 5,000 years. They can wait another 100 if they have to. Clay's got all the time in the world. Whatever the Sumerians wrote down, whatever message they thought was worth preserving forever, it'll still be there long after we're gone, waiting for someone curious enough to finally read it. The cyclical nature of forgetting. Let's talk about something that the Sumerian texts emphasize repeatedly: the cyclical nature of knowledge and catastrophe. This theme appears so consistently across different texts and time periods that it deserves more attention than it typically receives. The tablets don't present history as linear progress from primitive to advanced. They present it as cyclical, with ages of wisdom followed by ages of ignorance, periods of order followed by periods of chaos. The antediluvian kings reigned during an age of knowledge. The flood destroyed that age. The post-flood world had to rebuild, relearn, rediscover. This cyclical view appears in other ancient traditions too. The Hindu concept of yugas describes vast cosmic cycles of creation and destruction. The Greek philosopher Plato wrote about Atlantis, an advanced civilization destroyed by catastrophe. Hesiod's ages of man, gold, silver, bronze, iron, describe progressive decline from a golden age of wisdom. Are these all independent mythologies, or are they preserving memories of actual historical patterns? Did human civilization rise and fall multiple times before recorded history began? The mainstream archaeological answer is no. We can trace human cultural development back hundreds of thousands of years, and we don't see evidence of advanced civilizations rising and falling in prehistoric times. But what if the evidence was destroyed? What if the catastrophes were thorough enough to erase most traces? What if we're looking in the wrong places, focusing on land while the evidence lies underwater on drowned continental shelves? The Younger Dryas period, approximately 12,900 to 11,700 years ago, saw dramatic climate change. Temperatures dropped rapidly, ice sheets advanced, And then, just as suddenly, the Ice Age ended. Sea levels rose by hundreds of feet as glaciers melted, drowning coastlines worldwide. If advanced civilizations existed during the Ice Age, their coastal cities are now under 400 feet of water. We've barely begun to explore these submerged landscapes. Underwater archaeology is expensive, technically challenging, and difficult to fund. Most of the world's continental shelf remains unmapped and unstudied. Entire geographies of potential human settlement lie unexplored beneath the waves. Some intriguing discoveries have been made. The Bimini Road, an underwater rock formation off the Bahamas that some researchers claim shows evidence of artificial construction. The structures off the coast of Yonaguni, Japan, with their right angles and apparent terracing. The submerged ruins discovered in the Gulf of Cambay off India's coast, which some argue could be remnants of an ancient city. Mainstream archaeology generally explains these as natural geological formations that happen to look artificial. Erosion can create right angles. Wave action can produce terracing. Underwater geology is complex, and pattern-seeking humans often see design where none exists. But the definitive surveys haven't been done. The technology exists to map these underwater sites in detail, to determine conclusively whether they're natural or artificial. NASA's orbital imaging technology could be adapted for underwater archaeology. The same remote sensing tools that map Mars could map Earth's continental shelves, but the research doesn't happen because priorities lie elsewhere. And if evidence of pre-flood civilizations does exist underwater, what would that mean for the Sumerian king list and its impossibly long antediluvian reigns? What would it mean for the Sumerian claim that they were rebuilding civilization after catastrophe rather than creating it from scratch? The tablets might be more historically accurate than we assume. They might preserve genuine memories of an earlier age, transmitted through oral tradition until writing was invented to record them permanently. The mythological elements might be real events described in the only language available to Bronze Age scribes. This doesn't require ancient astronauts. It only requires acknowledging that human civilization might be older and more cyclical than conventional archaeology assumes, that knowledge can be lost and rediscovered, that our current technological age isn't humanity's first dance with sophisticated culture. The preservation imperative. One theme that runs through Sumerian texts deserves special attention: the obsessive focus on preserving knowledge across catastrophe. The flood hero isn't just told to save his family and animals. He's told to preserve the arts of civilization: writing, mathematics, craftsmanship, astronomy. The implication is clear. Catastrophes can destroy cities and populations, but preserved knowledge allows rebuilding. This suggests the Sumerians understood themselves as custodians of wisdom from an earlier age. They weren't discovering astronomy and mathematics for the first time. They were preserving and transmitting knowledge that predated their civilization. The clay tablets weren't just record-keeping. They were insurance against future catastrophe, a way to ensure that essential knowledge would survive even if cities burned and populations scattered. The library at Nineveh, where Layard found those crucial tablets in 1849, was exactly this kind of preservation project. King Ashurbanipal sent scribes throughout his empire to copy every important text they could find. He was creating a backup of human knowledge, understanding that empires fall and libraries burn, but properly stored clay tablets can survive millennia. His instinct was correct. The Assyrian Empire collapsed. Nineveh was destroyed in 612 BCE by invading armies. The palace burned, its walls collapsed, its treasures were looted. But the tablets survived, protected by the very rubble that buried them. And 2,500 years later, British archaeologists excavated them, bringing ancient Sumerian wisdom back to light. This pattern of destruction and rediscovery repeats throughout history. The Library of Alexandria burned multiple times, losing irreplaceable knowledge. Medieval monasteries preserved classical texts through the Dark Ages, keeping ancient wisdom alive until the Renaissance. The Maya codices were systematically destroyed by Spanish conquistadors, erasing most of what we might have learned about their civilization. Knowledge is fragile. Civilization is fragile. The Sumerians understood this in their bones, which is why they pressed their most important knowledge into clay, the most durable writing medium they possessed. Paper burns, parchment decays, but properly fired clay lasts forever. And what knowledge did they choose to preserve? Not just practical information about agriculture and trade, though those appear too. They preserved astronomy, mathematics, creation myths, warnings about catastrophes, descriptions of the Anunnaki and their teachings. This selection reveals what they considered essential, not just for survival, but for understanding humanity's place in the cosmos. NASA, ironically, does the same thing. The Voyager Golden Records, launched into space in 1977, carry information about Earth and humanity for potential extraterrestrial finders. The contents were carefully chosen: sounds of nature, music, greetings in multiple languages, images showing human life and Earth's diversity. It's humanity's message in a bottle, thrown into the cosmic ocean. But the Voyagers also carry something else: a map showing Earth's location relative to 14 pulsars, using the pulsars' unique frequencies as reference points. Any spacefaring civilization could decode this map and find us, even millions of years from now when stellar positions have changed. This is exactly what the Sumerians were doing with their astronomical texts and architectural alignments. They were encoding information about our cosmic address, our relationship to the stars, the cycles that govern our existence. They were leaving a map for future generations, or perhaps for whoever might come looking. The parallels between NASA's Voyager project and Sumerian knowledge preservation are striking. Both assume that important information should be encoded in the most durable form possible. Both select carefully what knowledge matters most. Both include astronomical information as essential context. Yet NASA doesn't acknowledge the Sumerian precedent. The agency that sent records into space for aliens to find won't study the records ancient humans left claiming aliens already found us. The modern search and the ancient claim. Let's dig into this contradiction a bit. NASA's astrobiology program basically works off the idea that life probably isn't unique to Earth. The Drake equation, a formula Frank Drake put together back in 1961, tries to guess how many civilizations are out there in our galaxy that might be trying to talk to us. Depending on how you fill in the blanks, you get answers ranging from none at all to millions. A lot of scientists lean toward the higher end. The universe is just enormous, hundreds of billions of galaxies, each with hundreds of billions of stars. Most stars have planets, and plenty of those planets sit in what we call the habitable zone, where liquid water can exist. The building blocks of life, the same basic chemistry we see on Earth, show up everywhere we look. With those numbers, it almost feels like life out there is just a matter of time. And if life pops up, evolution could easily create intelligent creatures. Once you have intelligence, technology doesn't seem far behind. That's the main reason NASA keeps searching for signs of life, why SETI scans the sky for radio waves, and why scientists study exoplanet atmospheres for hints of biology. It all makes sense, given what we know about the universe. But there's a problem here. If smart life is common, if civilizations keep popping up across billions of years, why haven't we picked up a single clear sign? Why do we feel completely alone? That's the heart of the Fermi paradox. Enrico Fermi summed it up with, "Where is everybody?" People have tossed out a bunch of possible answers. Maybe smart life is actually rare, even if the numbers look good. Maybe civilizations blow themselves up or collapse before they can reach out. Maybe advanced species get bored of exploring or talking. Some folks go further and say maybe we're in some kind of cosmic zoo, purposely kept in the dark. Or maybe, honestly, interstellar travel is just too much hassle and nobody tries. But there's another angle, one NASA doesn't really touch. Maybe we already found evidence of extraterrestrial intelligence. Maybe it's hidden in ancient stories and monuments. Maybe, just maybe, they visited long ago and left, or are waiting to come back, or wanted us to develop alone for a while. This version of the Fermi paradox isn't any wilder than the others. In fact, it explains a few weird things, like why ancient cultures all over the world got really good at astronomy, or why similar architecture and math show up in civilizations that supposedly never met, or why old texts keep mentioning beings from the sky teaching human stuff. The big pushback is always, where's the proof? If aliens came, where's the gear? Where's the tech, the artifacts, the undeniable evidence that couldn't have been made by humans? Fair point, but think about how fast stuff falls apart. Metal rusts, organic things rot, even our biggest buildings don't last more than a few centuries. After a few thousand years, almost everything is gone. The only reason places like Göbekli Tepe are still around is because they're made of stone, pretty much the only thing that survives the ages. If ancient visitors used advanced materials, stuff that breaks down fast or even cleans itself up, almost nothing would be left. Maybe they took their things when they left, or maybe their technology just looked like part of nature to people back then, so we wouldn't even recognize it now. None of this proves ancient aliens showed up, but it does show that not finding obvious evidence doesn't rule it out. And when ancient texts flat out say there was contact, shouldn't we at least take a closer look? NASA is willing to scan the sky for radio signals from distant civilizations, even though signals fade and we'd only pick up the loudest, most direct broadcasts. If visitors actually came here instead of just sending messages, SETI wouldn't find them. We'd have to dig into history instead. NASA sends rovers to Mars to look for hints of ancient microbes, searching billion-year-old rocks for the faintest chemical traces. They take the possibility of ancient Martian life seriously, even with almost no evidence left. But when old human stories talk about visitors from the sky, NASA doesn't investigate with the same curiosity. Isn't that a bit inconsistent? The double standard is puzzling. Ancient microbial life on Mars, worth billions of dollars and decades of research. Ancient intelligent visitors on Earth, not worth discussing. Both are extraordinary claims about life in the past. Both require extraordinary evidence, yet only one receives serious institutional attention. Perhaps the difference is that Martian microbes don't challenge our self-understanding. Finding evidence of ancient bacteria on Mars would be scientifically exciting, but wouldn't fundamentally alter how we view human history and development. Finding evidence of ancient extraterrestrial contact on Earth would overturn paradigms across multiple disciplines. And maybe that's the real issue. Not that the evidence doesn't exist or isn't worth investigating, but that the implications are too disruptive. That our institutions aren't prepared for what might be discovered. That maintaining comfortable ignorance feels safer than risking uncomfortable knowledge. The TABLTS, as time emaciations. Let's return to the physical tablets themselves, because they deserve more attention than we've given them. Each tablet is not just a historical document, but a time machine of sorts, a direct connection to minds that thought thoughts 5,000 years ago. When you read a Sumerian tablet, you're not reading a translation of a copy. You're reading the actual words that a specific person pressed into clay on a specific day. The cuneiform characters are as direct a transmission as human language allows across such vast time. No telephone game of copying and recopying, no layers of interpretation between you and the original scribe. This directness is rare in archaeology. Most ancient knowledge comes to us filtered through later sources. We know Greek philosophy through medieval Arabic translations of Roman copies of Hellenistic compilations. We understand Egyptian history through inscriptions written by scribes glorifying pharaohs. But Sumerian tablets often present raw data, unfiltered observations. direct records of what people saw and thought. The astronomical tablets in particular read like lab notebooks. They record planetary positions, eclipse timings, stellar appearances with minimal commentary. The scribes weren't trying to persuade or explain. They were documenting observations for later reference. This gives us direct access to what ancient astronomers saw and how they understood it. And what they saw was often remarkably accurate. The Mull, Apin tablets compiled around 1000 BCE, but containing much older material, list stellar rising times throughout the year with precision that requires centuries of systematic observation. The Venus tablets of Amisajuka record that planets' appearances and disappearances over a 21-year period with accuracy that allows modern astronomers to date the observations precisely. These aren't mythological texts. They're scientific records, and they demonstrate sophisticated observational methods and theoretical understanding. The Babylonian astronomers who inherited Sumerian methods could predict lunar eclipses months in advance. They understood that eclipses followed patterns, that these patterns repeated in cycles, and that careful record-keeping allowed prediction. This achievement is often downplayed by emphasizing that they didn't understand the physical mechanism of eclipses. They didn't know that eclipses result from the moon passing through Earth's shadow or blocking the sun. They just recognized patterns and used them for prediction. But this criticism misses the point. Modern machine learning algorithms make accurate predictions without understanding the underlying mechanisms in any meaningful sense. They recognize patterns in data and use those patterns predictively, exactly what Babylonian astronomers did. The lack of physical theory doesn't diminish the achievement of systematic observation and mathematical modeling. The Sumerians and their Babylonian successors were doing science. Not modern science with its theoretical frameworks and experimental methods, but science nonetheless. Systematic observation, record-keeping, pattern recognition, mathematical modeling, and prediction. Their astronomical tablets deserve to be studied as seriously as any other scientific achievement in human history. Yet they're largely confined to specialized academic journals and university seminars. NASA's educational materials about the history of astronomy usually jump from primitive skywatching to Greek geometry to the Copernican revolution, skipping entirely over the 2,000 years of Mesopotamian astronomical achievement that made those later developments possible. This omission erases a crucial chapter of scientific history. It also prevents general audiences from understanding how sophisticated ancient astronomy actually was, which in turn makes alternative theories about ancient knowledge seem more necessary than they are. If people knew that Babylonian astronomers could predict lunar eclipses mathematically without understanding orbital mechanics, they'd be less likely to assume that ancient astronomical achievement requires extraterrestrial explanation. If NASA educated the public about the real history of astronomy, including the impressive Mesopotamian contributions, the ancient astronaut theories would lose some of their appeal. But that education doesn't happen, and in the absence of mainstream acknowledgement of ancient achievement, alternative theories fill the gap, often exaggerating what ancient peoples knew while simultaneously explaining it through outside intervention rather than human capability. The weight of silence. We're approaching the end of our journey through this mystery, and the silence becomes heavier as we near the conclusion. Not the comfortable silence of answers found and questions resolved, but the unsettling silence of puzzles left unsolved and investigations never begun. The Sumerian tablets will return to their climate-controlled storage. The astronomical alignments will continue marking celestial events as they have for millennia. The questions about ancient knowledge and its sources will persist, debated by enthusiasts and dismissed by institutions. And NASA will continue searching the skies for life, ignoring humanity's oldest claims of contact. This silence echoes through museum corridors and university archives. It resonates in the gaps between what we know and what we're willing to investigate. It fills the space where honest inquiry should exist, but institutional caution prevents. And maybe that's the saddest part of this entire story. Not that ancient astronauts might or might not have visited Earth. Not that the Anunnaki were or weren't real. But that we live in an age with unprecedented tools for investigating these questions, yet we choose not to use them. We have the technology to analyze ancient texts rigorously, to test astronomical claims mathematically, to determine what ancient peoples knew and how they might have known it. We just don't do it. The excuse of limited resources doesn't hold up. NASA's annual budget exceeds $20 billion. The cost of comprehensively digitizing and analyzing Mesopotamian astronomical texts would be negligible in comparison. A few $1 million would fund the project completely, providing resources that could revolutionize our understanding of ancient knowledge. But priorities lie elsewhere. Mars rovers, space telescopes, asteroid missions, all worthy projects certainly. But wouldn't a complete understanding of humanity's astronomical heritage also be worthy? Wouldn't documenting how astronomy developed from its earliest beginnings serve NASA's educational mission? The agency that inspired generations with moon landings and Hubble images could inspire new generations by connecting modern space exploration to ancient sky watching, by showing that humans have always looked up and wondered, by demonstrating that the same questions NASA asks today were asked by Sumerian priest astronomers 5,000 years ago. Instead, the connection goes unmade. The ancient and modern remain separated by institutional boundaries that serve no clear purpose, and the silence persists. Perhaps you're thinking I'm being too harsh on NASA. Perhaps the agency has valid reasons for its approach that I'm not appreciating. Perhaps institutional conservatism and disciplinary boundaries are necessary for maintaining scientific rigor. Perhaps engaging with ancient astronaut theories, even critically, would cause more problems than it solves. These are fair points. Institutions must be careful about their credibility. Science requires skepticism and high standards of evidence. Not every question deserves equal attention, and some topics are legitimately outside an agency's scope. But I keep returning to the same thought. The questions are interesting regardless of the answers. How did ancient astronomy develop? What did early observers know? How was knowledge transmitted across cultures and through time? These are legitimate historical and scientific questions that happen to intersect with space exploration and the search for life. NASA could address these questions without endorsing any particular answer. The agency could fund research, support translation and analysis of astronomical texts, use modern computational methods to test ancient claims. The results might completely debunk alternative theories, or they might reveal unexpected sophistication in ancient knowledge. Either outcome advances understanding. But the research doesn't happen, and we're left to wonder whether the silence protects scientific rigor or merely institutional comfort. The final descent into sleep. The museum closed for the night. Everything's quiet now. The archives are dark, not a sound anywhere. Clay tablets just sit there in their containers, waiting like they've done for thousands of years. Each one holds a message, maybe a warning, a scrap of knowledge pressed into clay by hands that turned to dust long before anyone called it history. Outside, the stars turn overhead, same as always. The Sumerians watched these same stars from their ziggurats. They tracked planets, made notes, tried to figure out what it all meant. Those old questions, they're still with us. We build telescopes, send out probes, chase answers across the universe. Honestly, we're not so different from them. We look up, we wonder, we try to understand where we fit in all this. We search for patterns, look for meaning in how the sky moves. We write things down, hoping someone in the future will pick up where we left off, not start over from zero. The Sumerians actually pulled that off. Their discoveries survived. We can read what they saw, follow their math, admire what they managed to do. Their knowledge made it through 5,000 years, wars, disasters, empires rising and falling. But here's the twist. We've broken the chain in a new way. We stopped listening to their explanations about where their knowledge came from. We filed it under mythology and moved on, happy enough to be impressed by their astronomy while brushing off the stories they told about how they learned it. Maybe they got it wrong about the Anunnaki. Maybe those beings only ever lived in the Sumerians' imagination. Maybe they worked out the stars all on their own and the rest is just myth layered on top. But we'll never know, because we aren't even looking. We're sticking with what feels safe. We protect what we already believe, steer clear of questions that could shake things up. We're choosing not to know because we're afraid of what we might find. And maybe that's the real warning in those tablets. Not about floods or comets or lost civilizations. Not about ancient visitors or cosmic doom. The real danger is forgetting. It's what happens when a culture stops asking the hard questions, the uncomfortable ones. The Sumerians were scared of losing knowledge, of disaster wiping out everything they'd learned, of future people having to start from scratch. So they pressed their wisdom into clay, leaving behind records that could outlast almost anything. Our fear's different. We're afraid that new knowledge might mess with our sense of who we are, might force us to rewrite stories we like, might expose just how much we still don't get. So we stay quiet, and in a way, that erases things just as much as a flood or a fire. Both kinds of fear make sense, both protect something, but only one leads us toward truth. Tonight, as you drift off, picture yourself in that archive. You're holding one of those tablets. Its surface is marked with signs that survived thousands of years. Each little wedge throws a shadow, making the text stand out. You can't read cuneiform, but you get it. Someone real, someone with hopes and worries not so different from yours, made these marks. They thought what they knew mattered enough to last forever. They believed the future would need these lessons. They were right. We do need it. We need the whole story, even the parts that don't fit nicely into what we already think we know. We have to ask questions, dig deeper, keep the chain going, just like the first people who stared at the night sky and wondered. That tablet's message has waited 5,000 years for us to actually listen. It can wait a little longer, but not forever. Knowledge pressed in clay lasts, but if it's locked away, ignored, or dismissed because it doesn't fit our ideas, it's as good as lost. Go to sleep knowing the questions are still there. The mystery hasn't gone anywhere. And somewhere in a dark storage room, thousands of tablets are waiting, ready to tell their stories to anyone who's willing to listen, no matter where those stories might lead. The Sumerians spoke to you tonight across the gulf of time. Their words survived flood and fire, war and conquest, the collapse of empires and the erosion of millennia. The messages they preserved are still here, still readable, still waiting for humanity to take them seriously. NASA will wake tomorrow and continue searching distant stars for any sign that we're not alone. The agency will invest billions in that search, driven by the question that has haunted humanity since we first developed language and looked up at the night sky. And the irony will persist. The question that drives NASA's mission was answered 5,000 years ago by people who claimed they knew we weren't alone because visitors had come and taught them. Whether that answer is literally true, metaphorically true, or completely false, it deserves investigation rather than silence. But maybe tomorrow will be different. Maybe someone will read this and decide to ask uncomfortable questions. Maybe an institution will find the courage to investigate rather than avoid. Maybe the chain of inquiry that the Sumerians began will continue, connecting ancient observations to modern searches, human wondering to cosmic truth. Or maybe the silence will deepen. Maybe another generation will pass without serious investigation. Maybe the tablets will wait another century for humanity to be ready to listen. Either way, they'll still be there, patient, permanent, preserving their message for whenever we finally decide we're brave enough to hear it. Rest now. Let the ancient voices fade into the background of your thoughts. Let the questions dissolve into the approaching sleep. Tomorrow you can wonder again. Tonight just rest knowing that the mystery remains, that the search continues, and that somewhere in the darkness, clay tablets hold secrets we